that are close to what you are looking for. The next day of the matchmaking services, which is currently under development, is AI-based matchmaking. So we intend to reduce the intervention of the expert as much as possible and rely on algorithms in order to provide better matchmaking closer to your needs and provide the information, the artifacts that will better support your request. We have also lots of support starting from community spaces that is maintained by Fundbox, one of the partners of Smart for All, where you can find, you can look also for partners and across Europe, not only for open calls, but also for collaborations. We have also a dedicated help desk for open calls, and the idea here is to provide details and support how to apply for the Smart for All open calls. All these services are transparent through the Smart for All website, and we have the online proposal system. So the open call submission will be made online through the Fundbox platform that is also accessible through our website. So let's go to the heart of the Smart for All idea, which is the open call. Open calls are we are planning to fund over the next 4 years 67 external Pathfinder application experiments. This will be funded through a schedule of open calls that are targeting digitized transport, digitized agriculture, digitized environment, digitized anything. Who can apply? We can have universities or academic institutions, we can have SMEs or bigger companies, we have system integrators, technology providers. All these different kinds of participants should form consortia with a specific proposal, with specific guidelines that are already on the air through the guide for applicants we have delivered for you through the website. And the idea here is to support consortia, as I said. So physical entities, for example, just one company, just one person are not entitled for submitting. So we need consortia that will be cross-border. Regarding the eligibility criteria, the eligibility countries, all member states of the European Commission can join, also the associated countries, but as I said, our focus is also Southeastern Europe. So here we have a prioritized list of partners that we wish to be on the consortia that will submit proposals. And in order to support in this direction, as you will be able to read in the guide for applicants, we are providing 1 point in evaluation in the consortia, one additional point, I mean, the evaluation of the consortia that submit and a proposal that includes one of the countries mentioned here in red. This is detailed in the guide for applicants and the frequently asked questions. We have 3 types of PI experiments. The first one is KTEs. These are internship knowledge transfer experiments. We are funding people to visit institutes across Europe and acquire knowledge and transfer back to their origin. We have verticals, focused technology experiments, which up to 80K projects, 9 to 12-year projects, and cross-domain technology transfer experiments that are actually, the idea is to apply technology in different domains. Imagine, for example, that we have developed as a FTTE a highly high-end sensor that is super ultra low power and can be used in different domains, in agriculture, in transport, or whatever. So this is the main idea. Apart from the 67 KTs, we also plan to deliver 21 verticals originated from the consortium, from the 25 partners I already mentioned. So lots of experiments over the next years, you can imagine. Regarding the cutoff days, currently speaking, there is we're in call one. By end of July 15th, we are expecting submissions for the first for the KTEs, and 1st June we will announce the open call for the focus technology transfer experiment, and we expect submission till September 30th. This is the schedule already mentioned in the website, and where you can find also details about how to submit. The submission, the application process, as I said, it's through the online platform we are providing as a service. You submit your proposal. It's not a complex proposal, but it should be very well focused and well defined. We have the eligibility check. We have evaluation from external experts that will provide evaluation in a regular manner as European proposals are evaluated according to the same guidelines. We have consensus meeting and, of course, the final selection of the agreement, the signature of the agreement. The process is quite fast. Imagine that from submission to evaluation, the submission lasts only 2 months, and in 3 months you should have your agreement signed and ready to start. So we will do our best to speed up the process, not delay, because we realize that this is very important for the partners that apply. So how we can join Smart for All, how we can join our Smart for All family, our Smart for All network. So you can take advantage of the various services we are offering. For example, our newsletter, matchmaking services, submitting to open call, or using marketplace. Through these links, you can join Smart for All ecosystem, and gradually you will appear as a part of Smart for All map, where you can other companies can search for you, or also you can search for other companies or institutes. I would like also to urge you to follow us on social media because a lot of information is floating around. So follow us if you like, and in order to be up to date for the latest news of the project, latest activities, and of course funding opportunities. On top of that, we have people that act also as contact persons. So if the previous slides or the previous resources are not enough for you, you need more information, feel free to contact either myself or our excellent colleagues that represent Central Europe, Contacts East Europe, Radovan and Betim for the Balkan area, and South Europe colleagues from Spain and Greece. So that's for me. I hope I have not delayed too much. It was a bit fast because I know there's a time restriction. So I'm open to questions. I don't know, Radovan, how would you like to move forward?
Okay, now we can hear 2 questions for you, and after that, at the end of the session, we will have 15 minutes for more questions regarding the project. And on Wednesday 10 o'clock, we will have the other, let's to say, more thematic session devoted to the Smart All, where we will have more presentations and so on and so on. That means now exactly just now before the 2 questions, and then at the end of discussions, at the end of this session, we will use all the time for discussion, and I please you to remain up to the end of the session. Okay?
Radovan, before starting with the questions, I would like to stress what you just mentioned. It's very important to join tomorrow at the webinar from Funding Box, our funding expert in Smart for All, that will provide step by step how you can apply for funding. So I try to give you an overview, but Funding Box will give you an insight what an application means. It's a lot of knowledge compacted in half an hour. So don't miss it. It's very important. That will speed up the submission process a lot. That's as a recommendation from my side. And now I'm glad to answer your questions.
Okay, have we any question, comment for Nico and the Smart All opportunities? Have we any question? Okay, if we don't have any comment, Darko, do you hear? Are we hear you? Babunovsky.
Yes, I'm here.
Is it interesting for you for North Macedonia?
Yes, it's interesting, but it's a little bit out of my area. So, because mainly automation, this is like sensors and low power systems computing. So I have to think about it, you know, a bit.
Okay. Okay. Then now I will give word to Betim to highlight something, and then we will remind up to the end of the session, and tomorrow we will have precise dissemination of these calls and with webinar, and I invite you for the webinar. Nico,
Okay, I will be there.
It's okay, Nico, thank you very much for the excellent presentation about our project. It was excellent one. And I hope for some people, member of our consortium, they are not today online, at least to follow your presentation in YouTube. I think it will be great for everybody of us to see what kind of presentation you did, what kind of possibilities they are. In the meantime, to join us in the next activity here in MECO. To be part of our activity, all members of our consortium. It's very important. I think they have to know what you presented here, in which way, and how many possibilities there are, and to give such a possibilities to other colleagues, partners, and so on. This is very important project for Balkanic countries as well, but as well to increase the capacities in our area and to have an excellent cooperation with Europe. Thank you very much, Nico, for your presentation.
Thank you, Betim. What I would like also to mention here is that, of course, this is a fair stage of announcing, I would say, Smart for All over the next days. There will be available online video presentations and online videos explaining the Smart for All concept. So this is very important to join us through YouTube, for example. But apart from that, we are also planning a set of webinars that will be announced shortly, which anyone can join and attend. So our expert will be there to answer questions, to share ideas, explain what's expected from you and what Smart for All can do for you. And also there will be several local events organized. Your local ecosystems, the partners we have on board are actually represent different countries, different ecosystems. So they will definitely organize also webinars or physical meetings, info days, I would say, where you can also meet them in person and share ideas. So it's very important to stay in touch with us. And this is very important to make. We started as a 25-member family from the consortium, but we want to become a bigger family. And I stress on the fact family. We are here to support you, but also to support us in terms of technology and needs that you need to feed us in order to provide the right services for you. So I hope this will be a long-term relation over the next year.
Naim is waiting, and I invite you to hear the Naim presentation. It's very interesting because you are also university professor dealing with pedagogy. Okay, thank you.
Can I share my screen? Can you hear me?
Okay.
Give him the possibility to share.
Yes, Naim, you can share your screen, okay?
You can see my screen now?
Yes.
Tell me when to start.
Can we start? It's up to you, okay?
Okay, good morning, everybody. I'm sorry I'm not, we couldn't make it together this year. I think this topic here is very relevant to this new situation. So I have designed a few techniques to solve some of the teaching problems. Before that, I would just like to give you a quick review, and then I will show you what I have designed, a system that I call real-time feedback, and another system which I call it Smart Laser. I will promise you, you will see no equations, and I will make it very easy. So very quick introduction to put everybody onto the same level, then quick review of the technology that is available. And I will talk to you about this system, which I called Smart Pedagogue, and then I'll show you another system I developed, which is called Semi-Virtual Classroom, which I'll demonstrate, show you some videos on how it works. So the first thing, we're all educators, we all our fields, we teach this or that, and at the end of the day, we are educators, and we need to know, how to teach and what is pedagogy, and how can we see it in different angles. So the first thing, people talk about pedagogy, but what is it? First of all, pedagogy is not one thing. So we have to think about pedagogy as, first of all, a small subset of it, which is called the content knowledge. For instance, my content knowledge, I'm expert on digital signal processing, and that's what I'm teaching, real-time digital signal processing. Someone else is teaching something else, and that is your content. It doesn't mean if you know your subject very well, you're going to be a very good teacher. That is not enough. So what you need something else. You need something like a pedagogy knowledge. And that is how do you teach? How to set classroom, how you manage classroom, how you plan your lectures, how you set assessment, how you deal with students, how you answer questions, how you present something very difficult to make it very easy. All that is the pedagogical knowledge. So what you have to do for teaching, you have to put these two together, your knowledge and the pedagogy. Of course, the pedagogy comes with experience and studies as well. And then there's something else on top of that. Okay, so before that, you have to have these two. We call it pedagogical content knowledge. So this is integration of the subject expertise and the skills. So you have to have these two. And the third one is the technological knowledge. So for instance, now we are using Zoom, and you'll be using PowerPoint. And if you don't know how to use them, it's very difficult to be teaching. So basically, the technical knowledge is the knowledge and mastery of this technology. So you have to master that technology. If you don't, then it'll be very difficult. If you know it, then you could be making things very easy. For instance, we all use systems like blackboards and other device or other systems that I'm going to be talking about in a few seconds. But do you know them very well? Do you know how to use them? So in my talk, I'm going to be talking more about this technological knowledge. That's my interest at the moment. So for us as in education engineers, I think we should not wait for the technology to develop things for us. At the moment, all of us, all educators around the world, professors, they go do research, and then they go to the class and they give them to use PowerPoint or that system, and they may use it well or not well. But I was talking to Radovan a few years ago, and I said to him, Radovan, look, we need to do something on the technologies, on the education side. We are engineers. If we don't develop these things, who can develop these things for us? So as engineers and expert on our field, each one can contribute to the education side of it. And I will show you how I did that in my area. So for instance here, I'm going to give you a quick review, but before that, that all universities and schools, you have been forced to shut down, and then we're moving teaching online. That is a problem. And then we, as educators, I think we have to support this transformation. And then the demand has, increased, and then a lot of lecturers, they have now to choose how to use this system. There's many of them. There's so many, like Blackboard, Moodle, Canvas, this and that. I will show you a list. And then we are all forced to now to go and move online. And then we have to move very quickly. And then we say you have to move quickly and painlessly as possible. So guys, how can we move our online, and which online will we be choosing? So there are many systems, and we call them the learning management system, LMS. You may have heard about these LMS systems. In order to resolve problems of space and time, because at the moment we have problem of space. We have teaching in England, you are in Montenegro or somewhere else. That is time, and then space, and then also time. I'll be teaching here in UK. I am 1 hour ahead of you, and some people in China maybe 6, 7, 8 hours behind, and then we have to take that into account. So the systems now, as a learning management, may provide lecturers with class management, the content for the student. You can add assessment, forum discussion, quizzes, and the student can upload their coursework. They can see the feedback, they can receive marks, and so on. So basically, these LMS systems will manage the analyzer. So I will show you something about how to analyze the system, your courses, for instance. Run education courses. You can register students. You have a curriculum. You can manage it. And you can also have some reporting features, for just a simple one. How many people attended your class? How many people are focused in one area and not the other area? I could go for hours and talk to you about this LMS system, this learning management system. And then I put something on my slides, a reference here. Please go and have a look at this one. It's been published very recently, and he's got a list. And then it also has got comparison. You can compare them, which one to go for. And these systems, there are two of them. You can classify into. Some of them are open source, and some of them are commercial. Universities around the world are not opting for one or the other. For instance, my university is opting for commercial one, for instance, the Blackboard, and is supported by Blackboard. And we have another university next door is using another system which is open source. So there's division, which one is best, and that will depend on financial. There's a lot of other issues, support, and etc. There's also something which is sort of like LMS, which is Google for Education. You can explore that as well. I mean, if you are in education, you can have that one for free. And of course, you have to use their systems. I will not go through this in depth, but I give you some reference when you can have a look. I have a reference here. So let's go back to what I have done myself to support this technology here. The first, I was teaching over 500 students in one classroom. And I always had the same thing for many years. Some student came to me and said, it was very good. It was the right pace, perfect for me. Another one comes say, sorry, you were too fast. Another one says, you're too slow. And then how would you deal with that in a class? How would you sort out these problems? So the first thing is to gather feedback from students. So in e-learning, we're moving now from, especially now with the situation, we're moving towards two-way communication. So you have to communicate with students in real time. Using feedback tools can play a vital role and bridge the gap between online teaching and face-to-face, because face-to-face, student can just shout and then you answer the question. And then when you are online, that is quite difficult. But can we make it close? Can we close that gap? Again, I will show you how to do this. And also you have to keep students motivated. You have 400, 500 students sitting in different places. And like now in this conference here, I'm talking to you guys, I don't see who is attending. Is he interested, he or she interested? I am making them involved. You know, it's just like one way. I'm just talking. I don't know if you are there or not. So that's another thing. You have to keep students informed. You have to also support collaborative learning. So you have to have people collaborating when you're teaching them. Another very important thing that people tend to forget is that handwriting notes. I can put something on the screen or I can write it. If I write it, it will be more, students will remember it properly. For instance, if you have circuit diagram, you can just flash it on the screen, and then the student have to absorb all that you have been drawing for a few minutes in fraction of a second. So it's better to draw something on the screen. Now, if I'm drawing now something on the screen, how would you see it? Again, I will show you how I did that. Another thing, when I was doing this, my university was very keen. Other department, mathematics, for instance, they were saying, how can we capture a lecture writing by hand, especially in mathematics department? They don't like typing. Everything is written by whiteboard and chalk. So again, how you capture these lectures and how you give them to the students. So when I start gathering feedback, you have a problem. You have disparity in student knowledge. The students have different knowledge. And then that's why we are there. We try to put all the students at the same level. And it's hard to obtain feedback or information when you are lecturing. 400 students, how will you get information from students? How do you know what they know, what they don't know? There are many solutions that exist at the moment, but they are not perfect. So what we need something which is real-time communication. So what I want to be able to teach at the same time. When I'm teaching, I'm having feedback. How do we know what students know? How do we know that students are grasping what I'm saying? I'm saying something to you. How do I know they understand it or not? And another thing, how do I encourage you to ask questions? You know, for instance, Radovan asked 3 people, have you got any questions? And some people, especially students, they feel intimidated asking questions in the middle of 400 people. When you deliver, how we know that you're delivering at right speed? You may be fast, you may be slow, you may be fast for some, you may be slow for others. Again, can I have this information in real time? How do you gather also statistics? Because when you teach, you say, okay, I'll go for that speed. But maybe one slide is more complicated than the others. So how do you know that slide you had spent more time on it? Okay, now for getting the feedback, some students sometimes, they are extreme, or they have extreme opinions. Some of them have underrepresentation. So some of them talk too much, some of them don't talk. And then when you have feedback, when you try to get feedback, you're losing a lot of time. You don't have time to collect all that feedback. Imagine you have 300 students, each one is 1 minute. You're spending about 5 hours getting the information, and then your lecture is only 90 minutes. And the feedback also is often irregular, and sometimes you're missing some issues. And the feedback at the moment that is available, so what you say yes or no. It's binary, yes or no. Or sometimes you ask them a question and you say, is this value correct? And you just check that value. Though it's either binary or digital, which is not good enough. Can we find something else? So my aim was to create a tool that a teacher, me, and students, both of us, can have feedback. They can have feedback from me, I can have feedback on them, but in real time, and then without interrupting the lecture. That is a big challenge. So Yeah, and without the lecture. So I looked at this, and then you can have direct interaction with the student. The student can ask you a question. And again, as I said to you, that is not possible, especially with online. You have polling software. There are a few of them. And then there are, so they require the lecturer to stop the lecture, ask the question, and wait for the student to respond. And then sometimes you have tried these clickers, is an awkward silence there when I have to wait for all the response to come in. And sometimes not all the students are interested in this. Some of students are not interested, and then sometimes you just play with them. And sometimes the question itself is not relevant. Some students know it already. When I looked at the market and I say, okay, what is available on this feedback here? I found one system called Learning Catalytics. I don't know if you have seen it. This one, quite interesting. So basically, you are teaching in real time, and the student can interrupt you by pressing a button and say, "Don't understand," or send you a text message, and the lecturer can interact with it. So that is developed by Harvard University. Some people at Harvard, and then the person is selling this one here. So the system this design, when I started like this. I started putting my problem like that. I am the lecturer. I'm not perfect, so my transfer function is not flat. So I'm not perfect. I don't know the student, and this is my transfer function. I have all the students sitting here, and each one has got different understanding. I represent them by different functions here. However, I want to combine this with this one, or that one, or that one, or that one, to make sure that the transfer function is flat. So therefore, I needed feedback from each student. I have a system which analyze everything, tell me, I correct myself, adjust my curve, and everybody understand. So the way to do this, that in real time, sending text messages is quite difficult. Imagine you're in the lecture now, imagine my presentation now, and people sending me messages. How can I concentrate with my messages or my presentation? That is really difficult. So what I did, I transfer my presentation to the student, and they can see it on their tablet or their PCs. And then what they do, they just highlight the part they don't understand. I will show you a demo in a few minutes. So I don't understand, say that line here, I will just highlight it. And that will take a fraction of a second to highlight something on screen. You not ask questions, you just highlight it. So when I did that, it works extremely well when I tried it with a group with 30 students. However, when I tried it with very large number of students, my highlighting was a bit overwhelming because I had, the color coded wasn't enough. So basically I was obstructing my notes. So I said, can I come up with a better solution? And I found a solution where I can have a histogram instead of having an overlap of my text. I have the histogram on the side. Okay, the system I developed is this one here, which is at the moment it will be released. Well, the company will give it to me in the next 3-4 weeks maximum. It's called the Smart Pedagogue. Hey, it's got two things on it. It has got the real-time feedback, and then you have the smart laser. So you log in, and then you have the possibility to use these two tools. So this system, I call it Spotlight. So basically, a lecturer can come in, you can register, sign in or register, and then you can look at all your lectures here. So if I upload my lectures, I see them all here listed here, and I can just go and run my lecture. The next one here, you have the upcoming lectures. You can load your lectures in advance, and then you can run each one of them. Of course, each one of them, before you run it, you will select the number of students that you want to to be able to follow your lecture. So basically you have an Excel file of all emails, you put them in, and then you send the code to the student will log in, and then they can follow your lecture. You can also have access to all students, say who is attending, who is there. Okay, so this is what the lecturer will see when you upload your lecture. For instance, I upload my lecture, I can see who's present. I can see here, one student here highlighted this. He doesn't stand this, so he just highlighted. And I have another 2 students highlighted this too. I can see one here, another one there. And then I have a histogram here telling me, there's more people asking you question here. And then you can have more and more, and then this histogram will go up. Now we found another solution to solve this problem of, this color here when you have too many people highlighting. And then now in the next system, the student each student will have a different color. So you can tell who is asking what. You don't know the student, but you know that student asking this and this and that. And if someone is playing with the system, try to highlight everything or playing with it, you can tell who is playing with it, because of course you have to be genuine when you work with this system here. And then as a lecturer, you can hide the feedback. So if you don't want to see all this feedback, you can hide it. You can clear it completely, and then you can move to the lecture up and down. And also, when you are lecturing, in each slide, in the real time, it will tell you how fast are students saying to you. Some of them are saying to you, you have 25% say, please speed up. Another 12% say, please slow down. And the rest, they're not saying anything, which means you're on the right pace. So basically here you can, you're teaching, and then at the same time, you are adjusting your lecture. And then of course, this can be analyzed later, and you can see how much time you have spent on each slide. What's this slide here saying? Okay, student also can highlight, but also can send a text message. They can send me text messages because maybe I didn't get it. They highlight it, I answered it, but still wasn't that clear. So the student can send text message. Or I can give the student before running the lecture, they can highlight, and then also they have that time to put the text messages. So me as a lecturer, before running the real time or online lecture in real time, then I can go back and check my notes and say, look, a lot of people don't understand this. And then here's the question I have to answer. So when you come to the classroom, you're already prepared. You know what you ask, and you know where the student spends more time. Okay, so that's this one system, and I found it really useful. To be honest with you, I cannot teach without it at the moment, because I am always in contact. I feel like I'm really with the student because I'm teaching. I can see the highlight. My few lectures ago, I was teaching, and a lot of students were highlighting one thing, the word implementation. And I was amazed. I never thought about, most of the students didn't know the word implementation. How would you know? So you see about something like this, because they're shy. Nobody will ask you, say, what's the implementation, especially if you're teaching overseas students. So you see that they ask you questions that you would never, ever guess, because if you guess everything, you can prepare them. So this system is that you cannot guess. Let students, ask you these questions. So the system, the second one is the semi-virtual classroom. A lot of people complain about these LMS systems. When you are giving a presentation, you have a laser, and then you're pointing to a screen. That laser is not. Wait, yes.
Can I tell you that we have 5 minutes more because we should?
I don't have. Yes, I'm nearly there. Okay. So when you have a laser, you point it, and then you want to capture that laser and then show it to the screen. So I'm going to skip this one here and I'll show you a quick demo. For instance, here, my setup is I have a 360-degree camera, which is pointing at the whole class here. And then I have my my whiteboard. And I'm going to show you here, I am presenting the whiteboard, and this is what students see. So you see the quality is not the quality they have here. And then the laser, if you hold it and point it to the screen, you can see it will automatically zoom. So let me show you this demo here, since I have 5 minutes. So you see this, I have tracking automatically. So when I point to the laser, this is not the laser which was the real laser. So I pick up the laser with the camera. I know the coordinate, and I will go and put it into original image. And then if I need to zoom on somewhere, I will just hold the laser and automatically it will zoom. When it's zooming, I can just move around. And if I want to remove the zoom, you just click, let it go, and then it starts again, normal. So let me move forward and show you something else. Look at, I'm moving here. So imagine now I decide to go to the whiteboard, which is sitting on the corner there. So nobody can see the whiteboard. How can I transfer? So with the laser, I just point, and then my screen automatically displayed. So I'm writing there. I click on here. So you see, with the laser, I just point to different screens, and the screen will capture and send. I think I move to my, I think I'm on time. Have you got any question? The system will be available in the next few weeks. If you have any, if you want to try it, please email me and I will send it to you, and you can try it with your students, see what you think of it. And then what you need for the laser pointer, if you have many screens, then you just need a laser pointer, which is, you know, a few pounds, and then the software. Of course, you have to have a camera pointing to your whiteboard, or if you want to be tracked, another 360-degree camera. I think I finished. Thank you very much. Any question or question?
Naim, thank you very much. I now commented with Betim, very, very impressive talk. And I like to put this talk on the website of our conference for education purposes. Also, it could fit in our project related to smart education and so on, and invite you to use opportunity to apply for grant for this.
Yeah, I mean, I just got a grant actually, which is, you know, I got a couple of grants for it to develop the system with a very good company who's making this, and then it will be available. However, I need to apply for a grant to test it, to try it with other people. But the feedback, I couldn't show you the pictures because of copyright student. I had 400 students, and all of them, you know, overwhelming, saying they need that system badly because they can interact with you, and especially for the smart laser as well. It's quite important. But I can discuss with you, send it to you guys and see what you think.
Okay. Has anyone else question for Naim? Very short, 2 questions.
Hello, Professor Radovan. It's Adrian speaking. Can you hear me?
Thank you, Adrian. We hear you.
I wrote on the chat, but I'll be quick on the question. Professor Naim, so this is your own solution, as I understand. It's not something you bought it. My question is, because we are doing something similar without the laser, but this is a good, interesting thing. Do you use like OBS Studio to switch between cameras?
No,
Yes.
Everything I've done is my own software.
Because there is the one camera on the whiteboard, one camera on computer and one camera on you. And the switching needs to be done somehow with the software. This was my question. So you have built your own software, or you use like OBS Studio or something?
No, I use my own software, and the smart idea of this is that I just switch with the laser pointer.
Yes, exactly. And the last question, is this code going to be public open source, or is going to be commercial? This was the last one.
I think it's going to be commercial, because I think the grant is not, I got a grant, and then when they give me the grant, I have to sort of like give them some of the rights.
I understand. Yes.
To do that.
Thank you. Very interesting. Thank you.
Okay. Other questions?
Come on, guys. I need other questions. Otherwise, you have to highlight.
Okay.
If there is no other question, I will do a comment on the question name. Thank you very much, first of all, for your presentation. As a professor, old professor, still I get the possibility to see how we can improve the content. It means to be updated all the time that you mentioned from the beginning. How I can improve myself using and helping the others for technology. And every day from pedagogical point of view, we learn something. Your system looks quite good, and you offer a lot of opportunities. Only the main question that I have now is something like connected with disponibility and the possibility to be as much interested the students to participate in active in such an online system teaching. And in the meantime, a next one to follow it is how many % more hours we need, if you have an idea or can advise us, how many much more hours we need based on the face-to-face teaching. Because if we just can finish, let's say for 15 hours, the subject face-to-face, how many additional hours we must have to do online teaching and to be successful one?
I think from experience we have now, and I am the program director of computer science electronics, which split between two departments. And then what we have found is about 20 to 30% difference. So basically, for you guys, if you are teaching next year online, you have to make sure that you would drop the content by 20 to 30%. That's what I found out from different departments, and they are quite, aligned on that. You with me, Betin? About 20 to 30%. Now, with the system, I'm hoping to get students involved. If I can get them involved, then I can have, I'm bridging the gap between online and face-to-face. By having them interactive, then you're getting very close. So you'd reduce that time. But again, it will, of course, depend on the field. I haven't tested with different fields like in economics or chemistry, but in my field, I think I can deliver that lecture, I would say maybe 5 to 10% difference in terms of time. Because you are interactive, you are with students, you can see what they are asking. The only problem we have to think about, guys, because when we used to teach for 1 hour, 90 minutes, but now we cannot have students concentrating 90 minutes on online. So we have to divide it into chunks. Instead of giving 90 minutes, give them maybe 30 minutes and another 30 minutes. But don't give 90 minutes in one go.
Okay, Naim, because we are out of the time, and we should to listen the next presentation of our participant from Indiana University keynotes, and really thank you very much for your very, very good presentation, and I hope that we will find time for discussion regarding this topic. Thank you, Naim.
Thank you for
Thank you, Naim. Thank you very much.
Thank you.
Sharing screen.
Waiting first of all. It's online.
Okay. Šta, Martin? Da li se vidi? I ovaj Zoom.
Morate da stop share.
Pa kako ja mogu ovdje? No, neću da pustim ovo, da čujete.
Ne, ali treba stop share prvo.
Ali on ide prema njima.
Nema na Zoom, nije na Zoom. Morate stop share i onda opet. Kliknite to i onda ovo optimize for screen sharing.
Gdje?
Gore malo? Gore?
Hajde, dođi vam. Že, brate?
I ovaj sad izberem, jel?
Jest.
And Perry Mall, who just retired, but was. Hello, everyone. My name is Memo Doklic. I'm an associate professor in the computer science department at Indiana University, the Letty School of Informatics, Computing, and Engineering. And I'm very honored to be a keynote speaker at the 9th Mediterranean Conference on Embedded Computing. This is my first virtual keynote. So I hope you will take that into account as I work through my numerous slides, which I made too many of. I was given 15 minutes, and as a typical professor, I made probably 3 times too many. So we'll get started. This is an outline of what we'll talk about, the objectives, problems, and contributions, an introduction to the particular problem that we were facing at IU with its transportation system. There are 2 actual public transportation systems in Bloomington, but we were unable to work with the city for various reasons. The public transportation system is a well-known and studied problem, but IU brings some unique challenges to it, and we found some interesting successes that we'll talk about, and then we'll look at some of the performance metrics. This is work that was recently published in the Conference on Data Science and Advanced Analytics with 3 of my PhD students, an undergraduate, Logan Keating, and Perry Mall, who just retired but was manager for the IU bus system. So we wanted to use the myriad of data that's available, that has been available for the buses, to improve performance, and we'll talk about what IU has in mind for the next decade or so. And we decided that there was a need to build some infrastructure for all this sensor data before we could even begin to do some analytics. But the end goal was to create a data-driven solution that would provide what we're going to call goodwill. We'll talk about that. And one of the nice consequences was that we saved about 5% fuel and moved 15% more people with new scheduling done by an extended form of simulated annealing. So one of the challenges that we actually met when we began is that there were a lot of stakeholders in this problem. It's not simply making buses move faster or making buses larger. There are drivers that have set union rules. There are speed limits. There are a host of challenges that come together when trying to solve quite a bit, but most of the work that's been done has been looking at reducing costs, and that's really not something that we were able to deal with directly or indirectly. We had two significant data streams that we'll talk about, and then we enriched the data with the student classroom information. There are about 45,000 students on the campus, around 8,000 classes a day or so, and this was the way we were able to make sense of the streaming data. So the important thing always in data science is that we want to make an actionable solution. So we involved the stakeholders directly. This was IU Bus, and we actually worked in the IU Bus building, so we could talk directly to the folks that are driving and managing this component, vital component of our campus. We created several different things, but in this limited talk, I'll probably just focus on the interesting perspective that we took with modeling the elements of transportation, and then we'll look at the metrics that we used. We, as it says down here, were awarded a Campus Catalyst. This is for sustainability because we have saved so much fuel and reduced the carbon footprint. So this gives you an idea about how the bus interacts with students on campus 3 different ways visually. And what's important to draw from this is that the bus system, much to our surprise, really wasn't meant to simply shuttle students back and forth, but to move them from campus to parking. So this was an interesting element that we did not encounter in the literature. So IU is basically a square, as you can see on the left diagram, and parking is several miles north of where the university is. Each of the yellow dots is a stop, and there's various routes depending on where the students will be, their terminus, and typically where they live. So the idea is to bring them into campus. Some of that is transporting the students around the campus, but the campus is relatively small. One can walk to any part to the other within about 15 minutes. So the middle panel is times that students have. They're able to look on their phones and actually see the location of the buses. One important thing that we wanted to take into account was the pedestrian traffic, because IU is a very bike-friendly and foot-friendly city. And the campus is no different. You can see on the left panel all the different ways that people can walk around. This is important too because it reflects where we want to minimize the number of cars, and we're interested in promoting fuelless types of transportation or transportation that is efficient. So the center of campus is pointed by this yellow arrow, and this is where the heaviest congestion is since it's the central part of campus. And right north, which has one of our largest schools, the School of Business, also has a lot of congestion. So many of the problems we observed were basically traffic problems, in addition to simply not creating a schedule through data. our partition of where people actually live, since this was so important. And in the right panel, excuse me, the left panel, we're showing you really a sort of toy high-level graphic of what the campus looks like. So there are about 3 or 4 places where people want to be taken from and to while they're at school, and then they may take a bus to go to a class, let's say if there's inclement weather, but for the most part it's to move students in and out of the campus. So here is IU's goal. As you can see, we want to reduce single passenger automobiles by 20% and increase significantly the public transportation in the middle with the bus. Carpooling hasn't been as effective, although we do have a small pool of zip cars that students can use. It's quite bike friendly. The city is so small that a number of students actually walk to campus, but again, this changes with the weather when it's raining, or particularly in the winter when it's pretty cold. And on the right panel gives you some statistics that are important when we're looking at the problem. So the parking is, like most universities, a problem. There are more cars than there are slots, and depending on the day and the type of income students have, or their families, they don't mind taking up spots that are probably reserved for employees or faculty. We have a lot of buildings, as you can see, a significant acreage, but again, well within the span of 15 to 20 minutes. So this is the data flow of the system that we built. Each bus has a fixed transponder that has a sensor. There are drums along campus, and each sensor sends out a signal about every second or two, and it records the location and the time. And then there are lasers that are tripped for students that get on and get off the bus. This is important for us because in the beginning of the project, this was done manually with a clicker. So the bus driver would try to count the number of people leaving and entering the bus, but we found that those numbers really were so noisy that they didn't help us much. So we were very happy when we found that they were adding lasers. So the bus has this data local to it. There's a system on the bus, and there's GPS and then passenger data. And when the bus comes into the bus stall, it uses Wi-Fi to store the data. Then we do some data reduction. Much of my work is actually in data reduction. This is because I've found over the years that using Pareto's rule, we typically only need about 20 to 30%. Then this is where our application does its dirty work. We enrich the data with registrar information and create a schedule using an extended form of simulated annealing. And then what we do is check this against historical records. Obviously, there's a tremendous problem here validating a new schedule. First of all, you simply don't want to put out a new schedule because it may be worse than what you have. But what you can do is wind back time and see if the new schedule, given the types of metrics that you're interested in, would be an improvement over what you have. So there are various challenges that we face. Here's a list of a few of them. One of the things we did do immediately was implement a ghost bus service. It's a little bit tongue-in-cheek, but the idea was that if we found periods and locations where there was congestion, this ghost bus, would help by taking excess students. It really didn't have a particular route, and just this one element really helped reduce some congestion in some of the heavily populated parts of the campus, which I will show you with some heat maps. Another problem that we've faced that was really surprising is what optimization means. So as a typical computer scientist, I think of something rather simple, simply moving people, but in transportation, there are many different types of optimization, and we realize that given the constraints too of the university and finances and politics, etc., that we had a narrow window of things that we could optimize, and that's how we came up with goodwill. So the idea, and we'll talk about this, is that our model is that we have this interrelationship of goodwill. This is the likelihood, and it's not a probability, but simply a preference of a student to take the bus, which is tied to the cost of the maintenance, and by the way, it's free for students, and then the execution. But how this actually works in really is that the student simply sees schedule and then observes when a bus arrives and takes off. So the idea was, if we could improve goodwill, we could improve passenger rides, and so the number of passengers. And so how we would do that would be to improve the schedule that would match the expectation of the riders. Measuring the student goodwill, yet again, brought a new problem. So many thousands of students aren't willing to fill out a survey, and that costs money, and it's not clear it would yield the information that we needed. So we simply decided that we would use a very simple way of assessing goodwill. This is basically the delay or early arrival time of a bus, how it affects the goodwill of the student. Likely it's something Gaussian, but again, we just simply didn't have the resources, nor was it deemed feasible. This is used quite a bit, though, in industry. As a matter of fact, the PhD student Kurt, whose primary work was this, actually was hired at Wayfair and as a data scientist to improve goodwill of purchasing of products from Wayfair. So obviously, as a computer scientist, we would want to see if we could do something by brute force. And as you probably have already intuited, this isn't possible. There's combinatorially too many possibilities for generating schedules, and even with a number of constraints that we can place upon it, there's simply the search space is too large. So what is the best way to increase the customer satisfaction? So the idea was to look at reducing wait times and providing shorter travel times, that is, times between stops. A side effect that we put in here was reducing the negative environmental impact by reducing fuel consumption, but that honestly wasn't part of what the optimization problem took into account. But this model is where what we took as a ground truth and began working and extending it to our needs. So public transportation, many of the problems that are studied really are about connectivity. So you want to navigate through a large city, and so you want to make connections and you work with routes. That's not something that was allowable or possible in our problem, since most of the stops have been there for perhaps maybe 20, 30, 40 years. The only thing really we could do would be working with the timetables, which is really the strategy of managing when the vehicles leave and how many vehicles are on the road and so forth. So here's the obligatory minimization problem that we have, and you'll notice that there are many things here that we simply can't affect. So for instance, fleet size, that's not something you can simply buy more buses. Seating capacity is fixed for these buses. The total number of routes are typically fixed. So what we were doing really was trying to minimize the wait time, and then how fast we could get the students to their next stop without delay. So what's important to consider is the only way that students really get to understand where they should be is through the scheduling. And the scheduling is important because it affects the timetable. So the idea is that we wanted to use the GPS and the passenger data to fix the timetables. So how would we do that? It's an NP hard problem, obviously. So the typical solutions have been genetic algorithms and simulated annealing. And there have been some solutions for integer programming, much more simple problems than what we faced. As it shown here, by far, most schedules are actually simply just done by hand by domain experts. And as a data scientist, I believe that data can be used to improve decision making. So this is why we were actually approached. We did both simulated annealing, a form of it. We needed to extend it because I'll explain in a moment, and the genetic algorithm simply didn't work. Future work could be that we would be doing dynamic scheduling of locations, but students count on particular places being where the buses are. So at this time, really, that's not something that's possible. So again, I said that what we were trying to do was improve goodwill, and we could only really do this indirectly by providing schedules via the timetables, and the interaction is that the student sees the schedule and then picks the bus or waits for the bus to come pick her or him up, and then has a preference or lack of preference for using the public transportation. So our first naive algorithm, just to see what was doing, was to try to keep a certain distance between the buses called headway. The idea was that if we could find a way to keep all the buses relatively apart by a constant distance, that if you could think about it as a sort of a merry-go-round, that this would work. Unfortunately, there are some traffic laws that IU has put into place that buses can't pass certain buses, and then what happens is these buses tend to congregate all together, and then we I think we termed this caterpillaring, or someone did. So you'll see 3 buses in a row, which is strange, but this didn't really have much effect on the goodwill. And as you can see here, we made some mistakes with with some of the assumptions for this naive approach. So one of the things that we wanted to really look at for goodwill was when the passenger wants to leave and when the passenger wants to arrive. And what we realized was what was missing was actually data about the students. And that's what we have here as a backdrop of the heat map of one of the days at IU. So we actually took all the data from all the classes and assumed that each class had some number of students that would take a bus. We would split that up into blocks from a partition, and each block would go to a particular site that was nearest. And so what we did was simulate basically all of IU riding the bus. And we made some assumptions about how fast the students could get to the location from the classes and so forth. So we created some graphs of the students. So for instance, if a student was at the IMU, which is our main building, and was in class A, IMU is one of the central picking up points. How many seconds and how many students would go there versus Wells Library, which is a little bit northeast. And so you see we have a kind of SimCity of students. Then what we did was create a graph of the buses arriving and waiting at the locations. What we did find is that students were actually a little bit uncomfortable with buses that arrived too early, and obviously you didn't want a bus to leave earlier than the stated time, but then you didn't want the bus to leave too much after the stated time that it would leave. And so we have the data then that allows us to start calculating this minimization. And as I said, the search space was quite large, so we experimented with a couple of meta-heuristics, genetic algorithms, and simulated annealings. Simulated annealing won out. There are some challenges to it. One of the things that we did do, that we had to do, that is not part of the normal simulated annealing, is that as you move through the space, you actually changed the space for the schedules, because as you fill out schedules, other arrivals times become fixed. So there was a little bit of play there that we hope to publish on sometime soon. The GAs were a complete failure. And as a data scientist, I'm happy and proud to talk about failures. I think part of the problem is that for us, really, it was unclear how to take the good part of the genome, as it were, of schedules and make a better schedule. So timetabling, as I said, so we took all this data and then we were able to create a model of students taking buses and the buses arriving. We had these three elements of data. The GPS data, as you see, here's just a snapshot, which made the bulk of the data since the sensors were streaming every second. Automatic passenger counts, again, tells us when someone got on or when they got off, the location. We had to actually bring together all this data, because when it's recorded in the bus, it's not annotated such that we know a particular route is from a particular bus. I mean, we know the route, but we have to combine all these locations and times, because the only way we know, for instance, that a bus stops is that the sensor has the same GPS location for 2 minutes, let's say. And then when it loses the sensor and then comes to another drum on campus, then we know then the bus is there. So then we can calculate, for instance, how fast it's traveled. And then, as I said, we took the registrar data, which was all classes at all times, buildings, and the number of students that were registered to enrich the data. So here again is a little bit more detailed description of the GPS data and the automated passenger count data. And the registrar data, we were very surprised that so many students were riding the bus. Here's a screenshot of one of the heat maps that we did. We did many heat maps because classes vary depending on the day. So Mondays and Wednesdays at Indiana University typically are heavily, a little bit more heavily trafficked than Tuesdays and Thursdays for some reason. Fridays, even though the campus is open and has classes, these are typically laboratories or discussions. So the registrar data really opened our eyes as to how to generate the schedules. This gives you some idea of the size of perhaps one bus. And you can see the majority of the data is GPS data, but this takes into account just about everything we used. And with these building codes, we had to actually locate them on the map to know where they were with respect to the bus locations. So there are some fixed bus stops and some non-fixed bus stops. The registrar data was obviously pretty large per semester, and we found that interestingly, many more graduate students rode the bus than undergraduate students. The data reduction was significant for us. As I said, we did a great deal. So when the bus came, let's say almost 200 megabytes, and we made it 20 megabytes, the passenger count we significantly reduced to. We did some normal types of data reduction that isn't really pertinent to this talk, but it was worthwhile to help us create the schedules. So here's one of the performance metrics, and I know it looks rather simple, but it belies the significance. As you can see, the curve, the Gaussian-like curve, gets narrower. So in 2017, we actually were able to help the buses be more on time. So that's basically what this is showing. So we're showing the blue. So that what that does is that affects directly the goodwill of the students. The load profile is also important. So we increase passenger ride, the numbers of passengers, and this is basically a count of how many students are waiting. So you can see in the morning, and then excuse me. In the beginning at the stadium, and then again at the stadium, and then this is around the campus. Bus punctuality, I believe we might have seen this slide, excuse me. So how closely were we matching the actual data to diagnose the issues? As you can see here, this is actually where most of the parking for IU students occurs, which is near our athletic complex, which is some 2 or 3 miles away. And this tells us that we're not doing too bad. Sorry, I have that slide 2 times now. There are places where there's almost nothing we can do. So for instance, at the IMU, which is one of the world's largest student unions, it houses a hotel and events for many different types of communities, and also several restaurants, and even a bowling alley, believe it or not, and computing facilities. So one of the challenges that we faced is that when we came to spots like this, there wasn't really much we could do except help with the ghost bus. So another challenge is, as we were talking about caterpillaring, so we were looking at where does this happen a lot, and as you can see, it happens in the north part of campus where students are parking and waiting to get on the buses. So this was a place where we made sure that the schedule would help us. I don't know why there's 3 of those. I would like to thank everyone for inviting me as a keynote. I hope this was on time and within the 15 minutes. Vel, for inviting me, and the chairs, and the attendees, both real and virtual. As I said, this is my first virtual keynote speaker, Indiana University and IU Bus. Our future work is to try to do real-time adjustments of the scheduling. There are some challenges, though, with the university because they want the students to be able to count on the buses coming at a particular time, but I'm hoping to convince them that perhaps we can improve ridership if we're a little bit more flexible and let the data help us. So I hope you have a wonderful conference. I was very excited to actually travel to this part of the world that I've not seen, but I've heard Montenegro is one of the most beautiful places on the planet. So I hope sometime to come there. And I wish you all well and happiness and safety. Thank you.
Okay, thank you very much. Now we are 1 minute late, but we excuse. Now we'll start our session, regular session in 11 o'clock. Will be chaired by our moderator, Nikolina Brajovic. Nikolina, take the floor.
Good day, everyone. Shall we start this way? Can you hear me? Can someone tell me, do you hear me well?
Yes, we hear you.
Okay. Good day again. My name is Nikolina Brajevic. I will be your moderator for today's session. Currently, we are in the session number 13, software algorithms and applications. We have 7 presentations in this session. The first one will be determination algorithm of space objects covering type by using polyametric methods. It is a presentation by Ksenia Tipsikova, Nikita Tipsikov, Larissa, Irina, and Oleg. Do we have someone present here? If not, they have sent us. You can unmute yourself if you want. Since we do not have anyone present here, we will show their video.
Yes, of course you can just go share your screen by open your presentation, then click share your screen, click on your presentation, and you're unmuted. You can.
So here
Determination algorithm of space objects covering type by using polarimetric methods. Irina Bodrova, Oleg Bodrov, Larissa Rivkova, Nikita Tsiparkov, Ksenia Tsiparkova. Faculty of Computer Engineering, Rязань State Radio Engineering University, Rязань, Russian Federation. Near-Earth pollution is a global threat to humanity. Over the past decades, the amount of space debris has risen sharply. It is a threat to the Earth's orbital stations and biosphere. Polarimetric studies at the Rязань Observatory. Since 2010, studies at the Rязань University Observatory, led by Andrei Murtazov, have been conducted to study the scattering of light from space debris objects. This work is a part of a general study of the optical parameters of remote objects. Research goals and objectives. The paper proposes an algorithm for determining the type of coverage of distant objects based on image recognition methods. To solve this problem, the Bayesian approach is used. To determine the coating parameters of distant objects, it is necessary to classify the reflective surfaces as belonging to one of 2 types of surfaces, metal or dielectric. As a part of the study, the experiment was conducted with model objects on an optical setup with a polarizing block. Model experiment. The model experiment was carried out on an optical installation of a modulator type equipped with a polarization block. The Stokes parameters J, Q, U, and V are numerically calculated using 4 radiation intensity measurements. Calculation of Stokes parameters. The components of the Stokes vector of reflected radiation were obtained from the solution of a system of linear equations. Algorithm description. To compile the algorithm, polarization parameters characterizing the light beam reflected from the surface under study were used. Stokes parameters J, Q, U, V, and azimuthal angle alpha, ellipticity angle beta of the light wave. Constants are found for determining whether a feature belongs to the class of dielectric coating. The formulas you can see on the screen. To classify an object, it is necessary to evaluate the maximum allowable variance of each feature. It is known that the probability that the deviation of a random variable distributed according to the normal law. Find the probability of classifying an object by a class if this class is classified for each of the three attributes. In the case, classify the object with the class dielectric, otherwise with the class metal. For practical implementation of the algorithm, a program was compiled in the Delphi language. Conclusion: the algorithm has been developed for calculating the refractive index of remote space objects, which can be used to determine the optical parameters and types of surfaces of space debris of natural and artificial origin. The model experiment showed the following calculation errors by the proposed algorithm. For a dielectric model object, the absolute error in the calculation of the calculated refractive index compared to the reference index is 0.0008. The relative error is 0.055%. For a metal model object, the absolute error is 0.083 and relative error is 1.8%. To assess the stability of the solution, we use the variance of the difference between the exact solution in the solution with a noisy signal. The error in the calculating the refractive index of a model object compared to the reference indicator for a 1% noisy signal is 5.64%. For a 10% noisy signal, 6.32%. Thank you for your attention.
So we heard a presentation. Are the authors with us at the moment? I see that session chair is Mr. Milan Prokin. Mr. Prokin?
Yes, I'm here. Since there are no authors, then shouldn't be any questions because there is nobody to reply.
Do you want something to add or shall we go further?
No, let's go further.
Okay. Our next presentation is increasing of decoder speed in data transfer system due to the use of parallel calculations. Do we have here authors? Kirizeva, Ovekin, Bodorova, Koloreva, Simunkov. Miss Elena, I see you here. Good day. Miss Elena? Good day. We can't hear you very well. Can you? We have problem with the sound. You are unmuted, but we can't hear you very well. No. You should join the audio first.
S00, S01, S02, S0.
We can't hear you.
let's say. It was a very monthly stuff. Next presentation we have people who will the certain language and
Mr. Prokin, I recommend, well, due this issue, I recommend that we continue and to give Ms. Koloreva some time to fix her microphone. Is it okay?
Yeah, what is interesting is that I saw the, let's say, sound volume was active at the beginning, and after that, nothing. So I would suggest to, let's say, log out, or for Elena to log out from the conference and go back, say join audio, and after that unmute, as it is already unmuted. So she can try twice with the camera, without camera, but it seems that her bandwidth is sufficient for the camera, so it should be also sufficient for the audio. But it seems that it wasn't joined by with computer audio or something, as you already said.
Yeah.
So Elena, just try to,
yeah,
let's say, go out and go in.
So it's okay to continue, and we will wait for her until she's ready, okay?
Yes, yes.
So we have another presentation. It's an efficient Bernoulli probability distribution estimation of arithmetic coding. It's a presentation by you, Mr. Prokin.
Yes.
So we have a PDF. So it's up to you. You can share your screen and start presentation. Or you have...
I mean, if you are okay, you can show it. No problem at all.
Okay. I'm not sure that we have a video for that presentation.
Oh, it's not video, it's PDF.
It's a video.
Because I knew that I would be there.
Okay, okay. Just...
I mean, if you like me, I can share the screen, no problem at all.
I think that it's better that you share a screen, because I will need to skip pages. So it's better.
Okay.
So it's better because you know your speed.
So, do you see that?
Yeah, we see your whole screen. You should take a full screen. Yeah, that's perfect.
Okay, so this paper was written by my PhD student, Vladimir Čeperković, myself, from University of Belgrade, School of Electrical Engineering, and Professor Dragana Prokin from School of Electrical and Computer Engineering of Applied Studies. The story goes related to compression of all these data which we will receive from IoT devices, and whatever network we use, 5G or something else, I mean 6G after that, we will still have problems simply because of bit rate versus length of the link. You know, when people are talking about 5G, they're talking about some hundreds gigabits per second, etc. But they neglect that you can get hundreds megabits per second, as in case with 4G. with kilometer distances, but you will get a few gigabits per second only at very short distances measured in tens of meters, and all of that without even mentioning problems with attenuation or whatever kind of reflections which would introduce superposition of waves, which can of course increase or decrease electrical field. Long time ago, when everybody was talking about 60 gigahertz transmission for TV sets, so between a router in your home and TV sets, so no cables, you know, I visited 3 US companies which were developing that technology, and I proposed them a very simple experiment. Just put TV set into any piece of furniture made of wood, and you will get no signal at all. They were in the state of shock, and needless to say, after a year or two, they went into bankruptcy because, you know, they were always testing everything in free air conditions. So that's why compression will always stay with us as much more efficient way of delivery data. And this paper is related to improvement of state-of-the-art arithmetic coding, which utilizes finite state machines to select symbol probability estimates from the predefined finite set. That's usual state-of-the-art technology, but the problem is inherently limited precision and increased code length. And I will explain you why with experiments which we did. So in this case, we have not one, but two methods for Bernoulli probability distribution estimation based on low-pass filtering with O probability of symbols with varying dominant pole. So if you tell your students who are professors listening to me how to describe a low-pass filter with time varying dominant pole, I think that neither one of them will pass your exam. So don't do that, let's say, because it's really, really, really complicated. In order to make things even better, our solution utilizes integer-only arithmetics without multiplication or division operations, which are usual in state-of-the-art arithmetic coding. So it can be utilized in any kind of cheap and simple microcontroller, FPGA, and similar. So it can be used essentially in extremely low-cost IoT devices, even without specific ASIC tailored just for this application, of course, which is beneficial. So let's see the application. So one application is one-dimensional. I said audio encoder because audio is, you know, close to everybody, including us. But essentially can be any signal like seismic, heartbeat, you know, EKG, you know, whatever you can imagine, which is one-dimensional signal. So typical wavelet-based or some other technology-based, which we also developed, the composition of the signal starts from direct subband transformers, in this case one-dimensional ones, where you have low pass and high pass filtering, after that some delay lines, quantizers, and then the part which is of our interest are entropy probability estimators here, and after them entropy encoders. So this is the part which we improve, and after that you have a multiplexer for the output. So let's say if we have some symbols from the symbol set, and we know, of course, those symbols because we have chosen them to be short as codes in order to have extremely efficient state-of-the-art arithmetic encoding. We assume that that symbol sequence is generated by some kind of Bernoulli process with time invariant probability distribution, which is pretty much, let's say, excellent approximation of that what's going on in natural signals. So the probability of occurrence of particular symbol can be estimated from the first case symbols on one side using the maximum likelihood probability estimator. So in a nutshell, what's going on? If you have a signal which is, let's say, slowly varying, then we can easily figure out what will be the next symbol. If we have signal which has sharp edges, again, we can estimate the next symbol. Of course, we might have some overshoot at the end of that steep edge, but immediately after that, after some ringing, we can get the proper signal, which you will see in our experiment. So on top of that signal, we can add zero mean noise, which is usual, you know, when you have a natural signal, and on top of that, you have some equipment like microphone or EKG sensor or whatever else. So practically, and by the way, these equations correspond to that what I just said. So if we have probability of these symbols and the noise as two independent stochastic processes, which is also assumption which is valid in practice, we can say that power spectral density of the noise is constant over frequency. That can be verified by the autocorrelation function. And after that, if this symbol probability distribution is slowly changing, then the power spectral density of that probability now as our new signal which we want to filter out and compress, it's concentrated in low frequency range. So it's a narrow band signal, essentially. Which means that if we remove noise, which is on high frequencies, we can significantly improve signal to noise ratio. And that's what we did here. But where's the problem? With maximum likelihood filter, it's not possible to design an exact filter for non-stationary stochastic process as a closed form. I mean, like, okay, here is your signal and here is your equation, and this is how you should filter out optimally that signal. But at the other side, we can design the estimator which comes closest to the change in probability. And that's why we say it's equivalent to the maximal likelihood probability estimator. The problem is that this estimator requires division by an arbitrary integer. So actually, after the calculation, we will see what that integer will be. However, if we let's say look at the maximum likelihood estimator as a moving average filter with length which is equal to the number of elements in the sequence, then we can utilize assumption that power of two filter lengths are only lengths which are allowed. And in that sense, we can actually always divide by some power of two, which is essentially shifting, which means that we don't need either multiplication or division operations. On top of that, let's say that our first order varying pole filter is defined in, let's say, usual manner. Just in this case, it's time varying. Why it's time varying? Let's say you can see that first from spectral density, which is in lower frequencies. But after that, if you use ordinary low pass filter, which is stationary probability estimator, you will get something like this. Low pass filters are famous for not responding properly to signals which have a high frequency content, like pulse signals. And believe us, you can see those probabilities in natural signals. I already mentioned heartbeat. So the probability of symbols when there is no heartbeat is stationary, but after that you get sudden change in probability, and you have completely different symbols which describe high frequency content of your heartbeat. You know, it's very similar with the audio signal. Most people don't realize that there is something which is called crest factor, which means that we are not listening sine waves, which would be, let's say, air strike alarm siren. You know, what we are actually listening is music, and music has peaks and dips, which can have extreme difference in power, and that's why what it follows also difference in probability of symbols. So what we do with this proposed estimator with maximum likelihood filter and also first order filter is to track probability which has impulse response way better. Why? Because we simply say, okay, when we have a flat area of the signal, in that case, we will filter signal to be as close as possible to that flat area. And if signal suddenly changes, then we have to pass more high frequencies in order to, let's say, track that sudden change. Otherwise, we will have that on previous slide, which is pretty much useless for tracking for probabilities. And if you don't track probabilities probably, you will essentially have a bad estimation and let's say much bigger file size. So this is the code length which we got just for this tiny pass. Let's say it doesn't look high because when you measure mean and variance of particular signal, you can think, okay, this is just a little bit difference, but essentially it's a huge difference regarding quality of the signal. Imagine that you have one-dimensional signal where you have one, let's say, peak from time to time, and if you do that with stationary probability estimator, you will completely miss the peak, which means you will miss that which is essence of the signal. Mean means it's average over the signal. So if I have those peaks, I will still have an excellent mean, you know, no problem at all whatsoever, but I will miss that what is important. And that's essentially that what's going on with most IoT devices, because you know, most of the time they're doing nothing and then they have signal. And if you have probability estimator which is slowly changing, you know, probability, you will actually miss the signal. In our case, you will get those signals in spite of that mean doesn't look big, let's say, in a difference from the previous case. So, as conclusions, so this paper presents novel method for Bernoulli probability distribution estimation for use with arithmetic coding, which utilizes low-pass filter with time-varying dominant pole applied to auxiliary binary sequence to continuously produce estimated values without inherent limitations in precision. Since the arithmetic which is used is integer only without multiplication and division operations, this can be used in all processing power challenge devices like IoT devices, but of course you will get much bigger frame rates in a PC computer. So instead of having, let's say, something like 20 frames per second, you can get 120 frames per second. So, and that was the presentation. Thank you very much.
Thank you, Mr. Brocken. I was muted. You can stop sharing your screen if you want. So this year we have a little bit different organization. First, we will hear all the presentation, and after the presentation, we will have some time to make some questions or to add some comment. Is it okay for everyone? So I hope that Miss Koloreva is ready now.
You hear me?
Yes, good day. We can hear
good
you.
Day. Good day. You hear my presentation, or you see my presentation?
Yes, we see your presentation.
Increasing of decoding speed and data transmission in data transfer system due to the use of parallel calculation. Formulating of the problem. In data transmission system, it is often necessary to ensure the specified quality of transmission. The most common way to perform it is improving existing equipment. However, the construction of two high-quality communication lines is unnecessary waste, and it's simpler to ensure the required quality of communication using error detection and correcting codes. The number of computational operations necessary for encoding and decoding block codes with a high degree of error detection is growing exponentially with respect to the multiplicity of correctable errors, which significantly affects the speed of the decoders. This can have enormous consequence for real-time system. In addition, the modern rhythm of life requires quite quick access to necessary information by user. We offer the solution to determine the optimal composition of code combination and study the possibilities of corrective abilities. It is necessary to use the modeling of coding and decoding processes. The amount of simulation can be several times greater than the amount of calculation and are performed in a decoder. One of the ways out of this situation can be parallelization of computing processing in the generation, encoding, decoding, and transmission of the messages independently of each other. OpenMP and CUDA are some of the most common parallelization technologies that can be used as tools for modeling decoding operation. Modeling features. Hamming code 7.4, 15.11, and 31.26 are considered to calculate the efficiency of using parallel computations when implementing the message decoding algorithm. As the noise model, the implementation of algorithm uses additive white Gaussian noise. The user will specify the probability of bit distortion of the encoding message, after which a random error vector will be generated for each message. When the error vector bit equals 1, the corresponding bit of the code will be inverted. The algorithm modeling. 1. Generation of information message U with the length K. 2. Encoding and information message with a given code N, K, getting the word C. 3. Generation of the error vector E and its addition with the code word C modulo 2. 4. Calculation of the syndrome S from the received distorted code word E. 5. Determining the configuration of error according to syndrome S. And 6. Update the modeling statistic, determining of the number of generated, detected, corrected, and undetected errors. C++ implementation options. The software implementation of coding with Hamming code in C++ includes next simulation options. Simulation on the CPU using a single computer thread. Multi-threshed implementation with parallelization on CPU cores using OpenMP technology, and multi-threshed implementation with parallelization on the GPU cores using CUDA technology. Structural components of the program. The program implementation the following components. 1. Data source. 2. Encoder. 3. Data transmission channel, and 4. Decoder. Input data. The program takes the number of check bits of the code and the source data. When the program receives the number of generate message from the user and the probability of bit error and simulation mode, CPU, OpenMP, or CUDA as well. On the picture, you can see the program. We enter the number of check bits. We enter the number of generate message, probability of bit error, and choose the simulation, CPU, OpenMP, or CUDA. Output data. The statistics are displayed after the end of the simulation. It includes simulation time and the number of error detection. On the picture, you can see results of program and simulation node. We chose CPU on preview on preview, and simulation time 13 seconds. Code 3126, detected errors, and generation message you can see on the picture. Simulation results you can see in the on the picture. According to the simulation results, we can draw some conclusions about the efficiency of using parallel computer when modeling codes and decoding of block codes in the Hamming code version. With message vector lengths of 10 in 6 order, the simulation time was about 2 times for OpenMP and more for CUDA technology. Therefore, the OpenMP technology shows consistently high performance. CUDA technology can be applied in experiments with a large of generated message and large lengths of message. Since the performing calculation is scoped to the code and all placed of function calls, which is not advisable and in experiments with a short message length and small number of generated message. In general, the use of calculation of graphic processor has significantly accelerated the modeling process. Thank you. Questions?
Okay, you can stop sharing your screen. We will have some questions at the end of the session, so I please you to stay with us until the end of the session. Miss Elena?
Yes, I hear you. I understand.
Okay, now you can stop sharing your screen. Okay, thank you. The next presentation is the problem of designing the stack of technologies for man-hour distribution and analytics software. I see that Mr. Kotsenok is here.
Yes, I'm here. Hello.
Hello, good day. You sent us a video and a presentation. Would you like me to show your video, or you would like to pass through presentation?
Yes, show the video, please.
Okay, and then we will make some comments. Would you like to make some short introduction?
It's all in the video, so you
It's all
can
in the
just
video.
start playing it.
Okay.
Hello everyone, my name is Leonid Kotsenok, and today I would like to present you my work on the problem of designing the stack of technologies for man-hour distribution and analytics software. This article explores the problem of designing the technology stack for developing workload distribution software for modern project management systems. The following tasks have to be solved. Create an overview of tools used for workload distribution, form a set of criteria for choosing the correct technologies, compare the list of selected technologies, and formalize the requirements for development of workload distribution software. Resource management is among the most important management tasks in a company of any industry. These resources can be divided into two main groups: material and labor resources. Material resources such as raw material, equipment, available stock are spent by writing off their quantity or production cost. Such resources can be managed, controlled, and measured. On the other hand, labor resources consist of employees who perform a certain work. These resources, on the contrary to material, consume work time to complete a certain task, and their management is complicated. For modern IT companies involved in software development, labor resources is the primary type of resources. Therefore, it is important to be able to manage them correctly. Modern task management software used in software development allow to ensure control over the resolution of tasks by employees and project compilation. Although these products offer wide opportunities for setting up different workflows, but the capabilities of tools for analyzing labor costs are often insufficient to track the workload on personnel. According to the studies, there is a variety of problems with the employee time management. Among them are insufficient loading or overloading employees with tasks, reduced labor discipline, lack of control over which tasks are performed by employees, irrational workflow, not optimized staff size and workload. To solve these problems, the following tools for labor analysis can be used. The first one is a task burn-down chart, which is used in flexible development methodologies such as Agile and Scrum. It allows to evaluate how much work is left to do versus time, the number of completed and unsolved tasks using graphical representation. The diagram of plan to actual labor time allows to evaluate the actual use of resources by a single employee or team for tasks or projects in order to check the quality of initial task time planning and find potential problem areas. The maximum labor limit table by employee allows to find potential staff overload points and identify employees performing the most voluminous part of the project. And the last one is labor rationing table, which helps to identify employees who exceed the estimated time by tasks for the subsequent clarification of the causes of deviations. In addition, these data allow to calculate the real complexity of different project operations. In our previous work on this problem, it was proposed and explained why JavaScript programming language and GraphQL data transfer protocol are suitable for the development of workload distribution software. To choose the right stack of technologies for such software, the following list of libraries and frameworks has to be picked. For client-side application, base framework for front-end app, library for drawing charts and diagrams, library to work with pivot tables, and GraphQL client. For server-side application, base framework for backend app, and GraphQL server. The selected technologies were compared using the following set of criteria: the number of installations, which shows how popular is the software product in the development community, GitHub repository stars, which represent appreciation in the repository developers by the community, and the open issues to total issues ratio, which shows how fast the development team of repository solves users' problems and performs necessary corrections. As the number of libraries and frameworks to select is quite large, we won't go through all of them, but I will show the basic method on two examples. The first one is the base framework for front-end application. Based on the chart on figure 6 and the table on figure 5, React has the highest number of stars and downloads compared to other frameworks. Although its open to total issues ratio is slightly lower compared to Vue.js, much greater number of downloads suggests that React is the best choice. The second example shows the process of selecting a GraphQL client library. As you can see, Apollo client has the highest number of downloads and the lowest open to total issues ratio compared to other frameworks. Although it's almost the same number of stars as React Relay, superiority in other parameters make it a good choice for GraphQL client. Also, it can offer additional capabilities and optimizations if paired with Apollo server library. After performing a comparative analysis for each of the required technologies, the final system specification is proposed. JavaScript is chosen as the primary programming language for both client and server applications. React, Chart.js, and Pivot Table.js libraries are the base technologies for front-end application, while Express and Mongoose for backend. Data transfer between clients and server is handled by Apollo client and Apollo server libraries. Thus, if these technologies are used for development, it will be possible to implement all of the above requirements. In addition, containerization using Docker will make the technology stack flexible and scalable, thereby increasing the competitiveness of the future product. Based on the results of the comparative analysis, a set of instruments for labor distribution analysis was selected. A number of criteria were put forward, forming the set of required technologies to develop a web service. Besides that, the technology stack was chosen based on the results of comparative analysis, and the requirements for development of workload distribution software were proposed. This stack was made in such a way that it provides flexibility and scalability for the developed software product, offering a foundation for the future commercialization of the web service. It is planned to develop the web service in the near future and test it on real projects. Thanks for your attention.
So this was a presentation from Mr. Leonid. Mr. Leonid, do you want to add something?
No, but I will answer questions later if there are any.
Okay, so you will stay with us until the end of the session, and then we will have question and answer moment. I also see that with us are Mr. Mohammed and Haidari. They have a presentation regarding mathematical computations based on pre-trained AI model and graph transversal. Who will talk with us?
Hello.
Hello, Ms. Sommer.
Hi.
Would you like me to show your video, or you will do your presentation by yourself?
Well, I would prefer the video.
Okay, just a moment.
Begin.
It's the same thing. At the end, we will. Would you like to give some short introduction before it?
I think it's covered in the video, but as you said, I will stay till the end of the session for any question.
Okay.
Okay.
Okay, here we go. I will mute myself in order to skip technical issues. The curve, the Gaussian-like curve gets narrower. So in 2017, we actually were able to
Hello to all participants of the 9th Mediterranean Conference on Embedded
be more
Computing
on time. So that's
2020.
basically what this
Thanks
is
for your
showing.
attention.
So we're
My
showing
name is Omar
the
Mohammed.
blue.
I'm
So
a
that
master's
what
student
that
from
does is that
Electrotechnical
affects directly
University
the
of St.
goodwill of the
Petersburg,
students.
Russia, Computer Science Department.
The
I am pleased to introduce
load
you to an
profile
astonishing
is
approach both
also
involving
important. So
artificial
we increase
intelligence,
passenger ride,
specifically in speeding up
the
CPU
numbers of
computing
passengers,
process.
and this is basically
Working
a
tirelessly in the past
count
4 months enabled
of
us as
how
a
many
team
students
of 2 students.
are waiting. So you can see in the morning and then excuse me, in the beginning at the stadium, and then again at the stadium, and then this is around the campus. Bus punctuality, I believe we might have seen this slide, excuse me. So how closely were we matching the actual data to diagnose the issues? As you can see here, this is actually where most of the parking for IU students occurs, which is near. Excuse me. I heard the voice of a second presentation in this one. Did you hear the same thing?
Yes. Yes, it was like
two presentations.
Sounds were in one presentation.
One presentation. Ms. Sommer, do you have that video on your computer?
I would say so if you give me a second just to look at my files. Thank you.
Because it's much more better than to have this kind of technical issues. It was just a second voice of a different presentation on your slides.
I think I found it.
Okay.
So let me share my screen.
You can share your screen. Perfectly. We see your.
Okay.
Okay. Can you press a full screen?
Yeah, sure.
Okay, it's great. Thank you.
Hello to all participants of the 9th Mediterranean Conference on Embedded Computing 2020. Thanks for your attention. My name is Omar Mohammed, and I am a master's student from Electrotechnical University of St. Petersburg, Russia, Computer Science Department. I am pleased to introduce you to an astonishing approach of involving artificial intelligence, specifically in speeding up CPU computing process. Working tirelessly in the past 4 months enabled us as a team of 2 students, my classmate Said Haidari and I, alongside with under the supervision of our professor Alexei Paznikov of the same department, to come up with a paper research under title Mathematical Computations based on a pre-trained AI model and graph traversal, which will be our discussion topic of today. So, what's the problem here? In the past 15 years, we can say CPU, Central Processing Unit, have experienced a minimal increase, even though we know that today's processors are multiple processors and are capable of processing over 100 billion instructions per second. So why is that? Why CPU speed isn't increasing as it should? Well, the simple answer is because of hidden power. As we know from Moore's law, transistor size is shrinking on a regular basis. This means that more transistors can be packed into a processor. Having billions of transistors on a chip and turning them on and off thousands of times per second creates a ton of heat, of force. So let's say if the CPU usage is around 100%, this means that your computer is trying to do more work than it has the capacity for. This is usually okay, but it means that programs may slow down a little bit. Computers tend to use close to 100% of the CPU when they are doing like computationally intensive things. For example, like running games. So this is a problem. How to solve this problem? This will bring us to the main aim of our study, which we'll be talking about it in the next slide. So what's the main aim of our study? The main aim of this study is to reduce the execution time and complexity on CPU by involving artificial intelligence in parallel computing to make the CPU run faster. The main goal is not to compete with CPU abilities, but to assist it to perform faster, like we say. So let's take a look at some of the related works that have been done in this regard. As many of us might know, many programming libraries have been developed to solve one of the most common problems, which is performing arithmetic computation on big integer numbers. Big integer number, we mean that at least a number that is 18 digits long. Well, moreover, most of these libraries are designed to work over a single core system rather to work on a parallel fashion. We have taken an Avicen's as an example, and we found that these algorithms, no matter how good they are, they lack to the speed, of course, when it comes to compute to big integer numbers. So what's the motivations behind our paper? Of course, we believe that humans would not consider a machine, a computer, or anything intelligent if it were to process steps in a serial way, because it simply takes too long. Okay, now let's move to the most important and interesting section of our presentation, which is our proposed approach. It's an AI approach. In our paper, we have proposed an AI model that's trained on a set of numbers ranging from 1 to 8 digits long, with its corresponding targets to predict an accurate results. What we mean by that is we brought a set of 1 million integers, and we trained it to do one of the arithmetic operation, which is summation. So we took 2 numbers and we trained it on a summation. So the result was we created a model that's able to accurately predict the addition of two integer numbers ranging from 0 to 10 millions. It means that if a CPU got a request to perform an addition of two numbers within this range, 1 to 10 million, the CPU can confidently delegate that task to our model. And this is so important, especially when CPU is in need to do a huge amount of such kind of tasks repeatedly. We believe that delegating some tasks to our model will definitely reduce the load on the CPU, and it will make the CPU perform much faster. And you might ask why we use artificial intelligence to compute a summation between two integers, where the simple answer is because AI was the fastest. One interesting fact we've noticed, and it's mentioned in the paper, was our experiment. We noticed that our AI model, the execution time was faster than the CPU itself. But I want to emphasize again that the main goal is not to compete with CPU abilities, but to assist it in its calculations. Last but not least, we conclude this paper by stating that involving AI in arithmetic operations is still evolving, and this project might be a step towards improving such interactions. In the future, we aim to improve our model so it can cover other arithmetic operations like subtraction, multiplication, and division as well. Also, we are planning to implement it over a network of regular machines. Also, we will target to develop our model to learn in real time. That will be the end of our presentation. Thank you so much for listening, and stay healthy, stay safe. Okay.
Thank you, Mr. Omar.
Thank you.
You can stop sharing your screen.
Sure.
Just in the.
Okay.
No. You should stay with us until the end.
Yeah, I know.
In the top, I think.
Okay.
Right angle.
Here we go. Sorry.
Yeah. Okay.
Okay. And I want to mention something that the experiment was not presented, but I've talked about it. So I will be more than happy to answer for any questions related to the practical part. So.
Okay, just stay with us. We have 2 more presentations, and after that we will discuss everything.
Sure. Thank you.
Thank you. Mr. Prokin, you are also the next presenter. We have a topic regarding efficient cumulative probability distribution estimation of arithmetic coded by Mr. Prokin.
Okay, the same authors, but
the different
topic because there are 2 areas in arithmetic coders which can be improved, and this one is related to cumulative probability distribution estimation. So again, we have binary symbols, we have finite state machines, but the difference is that instead of low-pass filtering of probability of symbols, we are now low-pass filtering cumulative probability distribution of symbols, which is important in order to fine-tune the complete model in an entropy encoder. Again, this method utilizes only integer arithmetics, no multiplication or division operations, and that's why it can be successfully used in IoT devices. This cumulative probability estimation is, of course, used in both one-dimensional and two-dimensional encoders. This is the example of two-dimensional encoder starting from direct subband transformers, which provide both low frequency and high frequency filtering, but only low frequency filtering on lines, on pixels, let's say n lines, will be filtered further, while low combination of low pass and high pass filtering of either pixels or lines will be delayed, and after that quantized, and after that entropy probability estimated, and finally entropy encoded, which is, let's say, part where we made amendments. So again, we have sequence of symbols, but in this case, it's a time invariant probability distribution which is used, and the cumulative probability of occurrence of a symbol preceding the symbol can be estimated from the first symbols. First, we use maximum likelihood probability estimator, and in this case, it's also a combination of two independent stochastic processes, which is, we know, power spectral density of the noise, which is constant over frequency, and we expect that cumulative probability distribution is again slowly changing, so practically it can be a narrow band signal. However, everything else is different. So first of all, in order to use cumulative probability distribution estimate, we need either arithmetic coder or a range coder. Most people never heard about range coders, but believe or not, they were invented something like, let me see, 42 years ago. The reason is that their implementation is not straightforward, specifically because of multiplication and division operations. But at the other side, instead of providing one bit per output per cycle, range coder can provide a byte, word, 24 bits, whatever you say that it should be provided at the end. On top of that, so-called normalization process is much less often, which means shifting of internal variables in order not to be longer than word length of the processor. So practically, cumulative probability estimate must be scaled to an integer in the range 0 to total, where that total is a design parameter of the entropy encoder. It can be chosen to be a power of 2 in order to replace multiplication and division operations by left shift for multiplication, right shift for division operations. And in that case, we can always guarantee at least 16-bit representation of probabilities. Why 16-bit? Because it's sufficient for accuracy. But at the other side, if it is less than 16-bit, then we will have, let's say, bad estimates. If it is much longer than 16-bit, and we have, let's say, a 32-bit or 64-bit microprocessor, then we have to perform normalizations very often, which extremely slows down the whole process of entropy encoding. So practically, the scaled version is MPI, and a simple first-order filter with a varying dominant pole again is selected to calculate scaled integer cumulative probability estimate. The filter pole is constrained to the form which ensures that the multiplication by whole can be replaced by a subtraction and shift right operation. So that's why a transfer function is, let's say, limited to a power of 2 coefficients, as you realize. So the entropy encoder, of course, cannot operate with 0 probability. So that's why we have to provide a minimum limit also to be 1. At the other side, we can choose what will be our maximum based on this additional variable m, which practically is their utilization is defined here. So in a nutshell, we have both minimum and maximum cumulative probability estimates between, again, power of 2 and total minus m to power 2. So the final implementation is like this. As I said, this is completely different theory than previously, in spite of that some wording looks similar. The results are completely different because, as I said, now we have cumulative probability distribution. And the pole varying method is also different. It's based on maximum likelihood estimator. So again, we constrain the discrete pole to be a power of 2. In a nutshell, this parameter, A minimum, determines the initial speed of the adaptation. Because we have some adaptive histograms, you know, in order to check the probability. However, those histograms can't be changed instantly. So that's why we have to assume some initial speed of the adaptation, which should be as fast as the worst case possible scenario, which means fastest change in probability, in cumulative probability. At the other side, A max determines the steady state estimator bandwidth. So we are sure that we will track cumulative probability distribution change in flat areas too. And this is how the cumulative probability estimation looks like in case of stationary probability estimator. So again, when you have a pulse change in cumulative probability, initially it looks good, but after that it simply doesn't follow the signal. You know, long time ago, but that was really a long time ago, like 30 plus years ago, I made a special algorithm for tracking frequency change. So, you know, many people was measuring frequency using frequency meters, but practically all of them utilize switching between ranges. So if you want to measure 10 megahertz, for example, frequency, you have one range. If you have 1 hertz frequency, you have another range. Why? Because measurement methods for frequency literally depends on a frequency, because you can't use, for example, that's normal way of thinking, something like 100 microseconds sampling rate in order to measure 1 millihertz. Why? Because within those 100 microseconds, you won't see a single signal. Right? Actually wrong. So I figured out that you can utilize as low as you like sampling rate for any frequency. So you can measure 10 megahertz and 1 millihertz with exactly the same sampling rate, like 100 microseconds only, without any problem at all, because if there is no pulse within each cycle, you will just increment cumulative numbers. And practically when first pulse arrives, you will calculate the frequency. So essentially, you don't know if your next signal, and in this case symbol, will appear when and which one, but you can simply estimate probability of symbols on, in that case, let's say frequency, by simply saying, okay, this is the maximum frequency which we can detect, which means it can be lower than that, it can be higher than that. Current method simply with the lack of pulses say, okay, we will wait forever for the next pulse, and of course we will have bad estimates. So we utilize that 30-year-old technology to solve current problem, and this is what we've got. So practically we decrease probability estimate to be the best possible, and of course whenever changes are made, we can follow that way better than in a classical stationary model. And of course, we've got much better values over here in comparison with so-called ideal estimator. And again, if you think that these numbers are small, I can tell you that at the end, they result in better than JPEG 2000 quality for two-dimensional images, with something like 120 times faster compression. So just in order to give you the idea, when you have a accumulation of small tiny results based on the average, you have huge numbers in case of both speed and the quality. That was my presentation, and regarding conclusions, let's say this is a novel method for cumulative probability distribution estimation, specifically made for arithmetic coding, but also applicable for range coding. And in this case, we much better track changes in the cumulative probability distribution. And it can be used in all IoT devices because it's integer arithmetics only with simple low-pass filter, but with time-varying pole, without any multiplication and division operations. Thank you very much.
Thank you, Mr. Brokin. Our last presentation in this session is a presentation of Vasily Pilenkovic. I see Mr. Vasily here.
Hello, do you hear me?
Yes, we hear you. Your presentation is a method of testing and debugging flow formal specification of full stack embedded system design. The biggest issue of this presentation is that your sound on the video is not good. So it would be nice if you can present it by yourself.
Okay, I'll try to present.
Our video is so low that you can't hear the sound very well. So you should do it by yourself right now, okay?
Okay, do you see my presentation?
Okay, we see it, nice.
So let's start.
Okay, let's start.
My name is Vasily Pilenkovic. I'm from ITMO University from St. Petersburg, Russia. The problem is considered here is embedded system design. And as you know, practically every embedded system design is unique and implement a custom design flow. So such design flows are almost an ad hoc composition of various off-the-shelf and in-house automation tools and manual procedures. And this leads to design gaps in the design flow, which are the main source of errors in design. So the method to get rid of these errors is testing and debugging in a broad sense. So we believe that unification and formalization of testing and debug activities can help to bridge design gaps and reduce the number of errors. The existing approaches here are the well-known V model, but this is a rather superficial and very descriptive concept to use in real design practice. Then we have some platform-based approaches based on unified representation of system designs. And we have a lot of industrial tools that work on the implementation level. And these tools offer some automation for some small parts of design flows of embedded systems. So our approach is as follows. Let's model a system as a unified hierarchy, a translation hierarchy of representations from initial specification to target implementation. Representation here is some implementation of a component of a system or a system itself created within some computing platform at some abstraction level. So the representation includes all the artifacts related to the implementation and the testing and debugging activities, and also it includes errors if there are some errors. So these representations are connected by translation relationships, as you can see here at the picture. The picture shows an example of hierarchy for embedded system, which includes a microprocessor on a custom printed circuit board. So the structure of representation here includes two parts, the implementation of a system and the tests used for its validation. And we have four flags or states of the representation that are shown here as some checkboxes. The representation may exist or does not exist now. It may be verified. Validation tests also might exist or not exist, and representation may be validated. So representations are populated in the hierarchy during the design process top-down, and the validation tests are populated from bottom to up. Here we have translation for implementation and translation for validation tests. So if we introduce all these flags into the hierarchy, we obtain the labeled translation hierarchy. The example is shown here. It is example of the previous system. So we have the combination of all checked states as a current state of our design. So we can see what implementations we have, what implementations we have verified, validated, and so on. So to model the testing and debugging flow, we should provide more details, and we introduce the model in the form of a labeled transition system. We expand each level, each representation into a typical fragment of a transition system and form a big transition system of states we have in our design. So the structure of the design flow matches the structure of the translation hierarchy. So let's see what states we have in this transition system. We have the branch the top-down branch. When we obtain the representation, we have it ready for translation, then we have it translated and ready for verification. And the last step, we have it verified. If there are some errors, we should go back to fix these errors. And we have the bottom-up branch when we obtain validation tests and do validation procedure. And also we have the possibility to meet errors, and we should go back to the implementation branch to fix them. So this is a generalized structure, and it should reflect some real tools and some real levels. So this structure have some variants for different different representation levels. The uppermost level have the special fragment, which is shown here when translations are formal, for example, as a compiler or synthesizer. We also can skip some steps and states. And at the lowest level, when we obtain the validation tests, also this level has a special structure. As a practical application of this approach, we applied it to analysis of standard testing and debugging flow of system on FPGA with a soft processor. The translation hierarchy is shown here, and identified some gaps in design flow, mostly in implementation levels and in validation procedure, and formulated requirements for advanced testing debugging methods. And we developed a method of embedded system testing and debugging based on a high-level record and replay of the computational process, and developed some automation tools to support it. And you can read about this in other articles by the same authors. So here in the table, some numbers. We identified total 21 gaps. With standard methods, 12 gaps were breached, and with our method, we breached 7 more gaps. So as a result, we suggested a unified ontology of embedded system testing and debugging processes focused for systems with multi-level organization, and described an approach to formal specification of testing and debugging flows, and so also show some application examples. Thank you for your attention. I have finished, so you can go on. We can't hear you. Your sound is shut down.
Excuse me, I totally forgot it. Thank you, Mr. Vasily. Those were all presentations in this session. Now I'm giving a word to Mr. Prokin. Can you give us some comment of this session?
First of all, it's usual in live sessions to first ask everybody else for the questions, and if there are no questions, then people who have to provide questions are those who lead the conference. So let me ask everybody about questions about all of these 7 presentations. I mean, we have
We had
sufficient number of people in the chat.
Yes. We had the first presentations, determination algorithm of space objects, but the presenters were not in the session. So we can skip that.
Yeah,
Ms. Koroleva have presented us her presentation, increasing of the coder speed into data transfer systems. So do someone has a question for her, or does she want to tell us something more about her research? Miss Elena?
I wait questions.
Okay, if nobody has a question, I have one question which is related to speed increase in on certain platforms like CUDA versus ordinary, let's say, CPU. You mentioned twice and 4 times in increase in speed,
Yes.
but I don't remember a number of threads with which you perform testing.
Number of threads which excuse me, CUDA technology, господи, так, CUDA technology presents several threads, and I don't know how more it's used, because it is in programming, and I enter our input data, and CUDA decided how more threads they need.
I mean, my question was related to, was that the same number of threads, not the absolute number, but the same number of threads or more threads added, you know? It seems to me that more threads were added, and that's why we've got the acceleration.
Okay.
Okay, so let's go to next one.
The next one, that was your presentation, efficient Bernoulli probability, distribution estimation for arithmetic coding. Maybe we can ask participants if they have any question for this or for your other presentation, because they have some kind of similarity. No one on the chat. No one is speaking. What about Mr. Leonid's presentation, the problem of designing the stack for technologies for man-hour distribution and analytics software? Mr. Kusenot?
Yes, I'm here. I'm ready to answer any questions.
I don't see any questions. Do you want something more to add, something to share with us?
I don't think so. The research work I've done is a second part of the research. So the first part was presented on IEEE conference in St. Petersburg this winter. So this is more specific about the tools that can be used to develop such software. In the first part of the research work, I explained why such software is needed for modern IT companies.
Okay.
So I think that's all.
And I have a question. Well, I'm not from the field of electronics, but I want to know, are you planning to make some kind of a project in order to put your idea on the market?
Yes, the such software is currently developed in my bachelor work. So I've already mostly finished, and it is now being tested in a company that is in a field of software development. So we will see the results very soon if this software is efficient and is helpful for the company.
Okay, thank you. After the presentation of Mr. Mohammed, he told us that he is more than ready to answer everything that is related with his research. Mr. Omar Mohammed?
Yes.
Your presentation was mathematical computation based on pre-trained AI model and graph transversal.
That's true. If there's any question.
Mr. Prokin, do you have something?
Yeah, as a matter of fact, when you mention in your presentation that you are using AI in order to accelerate addition, specifically repetitive addition, what is that what you actually meant? Because, you know, addition is one of the fastest operations on modern CPUs. Division is, let's say, different. But where is that, let's say, acceleration? You said that you didn't provide, let's say, experiment results, but I suppose that you made some experiments, let's say.
That's true. Well, we picked addition as an example. We target all the rest of arithmetic operation, like you said, but we took the addition as an example, as a sample to use it for our presentation. And the experiment is clearly mentioned in the paper, the actual paper research, and I can give you actually the results, and I can give you a hint of how we did that. So the result was let's make it simpler. We took two numbers, like 1 + 1, for example, and we entered it in a supervised machine learning. Supervised, it means you showed the input and you showed the output. And we trained our set on 1 million set of integers. Like we said, 1 + 1 = 2, 1 + 3 = 4, and so on. And then we compared, at the end, we compared the speed of the CPU. As we know, CPU, when CPU is doing the summation, in our case, we all know that it uses the other gate, and it's on binary level, so it's low level, and it's quite fast. But the interesting thing was the speed of that calculation for the CPU to calculate, to do the summation of two numbers, took 1.30 nanoseconds, while our model that we trained on that big set of big numbers, it took it 1.10 nanoseconds. So we have 20 seconds difference. And that's interesting. But again, the goal is not to like say, okay, I want to compete the CPU with its calculation. No, it's like, hey, CPU, you have a friend. If you have a lot of operation that you see that it's repeatedly, we can track your behavior, and we can help you with these calculations. You don't have to do these calculations. We have a friend that's slightly faster, and this will help you in your performance. So that was the goal, the key of the presentation.
Okay, the reason why I was asking this is because it's unusual to apply artificial intelligence on, let's say, simple tasks, because people typically use them for extremely complex tasks which can't be handled by, let's say, usual knowledge or usual algorithms. For example, one of them is artificial intelligence-based real-time traffic management using all kind of sensors from cameras, inductive loops, passive RFIDs, air pollution, weather sensors, etc. So there is no person in the world who would make a proper algorithm for this. You can just provide the guidelines and then the rest will be done by artificial intelligence. But in your case, you actually took something which looks simple at the beginning, and then use artificial intelligence on that. So it's interesting approach. Thank you.
Exactly, Professor. The thing is, we have and we know a variety of machine learning, like, for example, simple neural network, recurrent neural network, and so on. But the goal is the rest of the high level, how can I say, algorithms. When you took them apart, you will see that in the low level, it's made of either addition, multiplication, subtraction, and division. So why not target that at the beginning and then follow the steps? That's something that we see that will improve, that can improve the CPU in general, the CPU industry. We hope to make.
Great.
Yeah.
Thank you.
Thank you.
Okay. We also had a presentation by Mr. Pinkevich. It's a method for testing and debugging flow formal specification in full stack embedded system designs. Does anyone has a question for Mr. Vasily? It was a very interesting topic. Mr. Vasily?
Yes, I'm here.
Would you like to tell us something more or something to add about your research?
Maybe I would like to add that this is rather early steps of our research. So we have this idea, but we don't have enough, mathematical formal models for this method. But we believe that unification of formalization of design flows is the key to improve the quality of designs and to improve speed, predictability, and so on. But unfortunately, not a lot of works in this topic, and not a lot of progress is in this topic.
Okay. Due to my mistake, we have a skip presentation of Mr. Steve Pierce. Mr. Pierce, are you with us?
Hello, yes, I'm with you.
Okay, we have your presentation regarding the digital and analog interactions process chain networks for the design of service process. Should we broadcast the video now? And after that, we will discuss it.
Yes, thank you very much. That would be great.
Thank you.
Hello, my name is Steve Pierce. I've had a career as a professional manager running service businesses at board level for around about 35 years. I originally trained as an engineer and now I'm currently a senior academic at the University of Bristol, where I teach a unit on digital business. Today I'd like to go through some service design theory, specifically around interactions between customers and their providers, and then look specifically at a service design process using PCN analysis and apply this to two cases, one on mobile money and the other on higher education. First, of course, I must define service and service operations management. And services are production processes that act on or with customer resources. So customers bring an input, their self, their belongings, or their information. Service design theory consists of three components: a service concept, what is the product or bundle offered, a service process, and a service encounter. For this work, I am particularly interested in the service process and service systems that surround the processes. And by systems, I mean the customer's behavior as well as the relevant IT systems that support the interaction. The service design theory, using unified services theory, helpfully defines customer inputs. These include the self, the customer's belongings, and the customer's information, and also state that the customer providers should actually add value to these customer inputs. And these inputs are made using a number of interactions with service processes. There are typically three types of interaction. There is direct interaction, which is face-to-face, people interacting face-to-face, and in this example, maybe in a bank. Surrogate interaction, where a customer is interacting with the resources of the provider, and in this case an ATM machine. And finally, independent processing, where an entity is acting only with its own resources and, for example, installing or updating an ATM machine. It's necessary to consider the design of service processes by these three regions. And here is the overall process one would use to analyze. Particularly looking here at the structure of the map here, you can see the direct interaction, the face-to-face, would be in this sector, and the surrogate interaction would be in these two sectors, this one for the provider and this one for the customer, and then finally independent processing is sitting here. And particularly in this example, this shows the old traditional way we used to work with libraries, and you could see how someone would go to the counter, return their books, go back and select more books, then go and check those out, etc., etc. So you can see there was a lot of direct interaction and face-to-face activity in the old traditional way we used libraries. So what effectively this methodology does, it analyzes the process steps by the type of interaction and customer input required. And then there is a further phase of interaction which starts to identify the value and other service design factors. Let's look at this in a little bit more detail in one of our case studies, a UK challenger bank. Here the process is opening a bank account, and in fact the process time is less than 5 minutes. And you can see what has been completed in the design here is there is no direct interaction. There is a lot of setup activity by the customer independently on their phone. And then there is a lot of surrogate interaction by the customer in downloading the app, entering details, recording a video, using fingerprints, using other security documents. All this is done by the customer here. And then that customer information is sent completely independent for independent processing by the bank, and basically an algorithm makes the decisions here and then issues the account back to the app, and the customer then has a full bank account service operating all within 5 minutes. My second example shows the UK higher education system, and this time multiple processes mapped across the PCN analysis. And you can see here a typical module or unit, and you can see that some of the activities are surrogate, where the student does work on their own but uses the university's materials or resources. And over here we would use information from the student to perhaps assess or grade or do those things. And in the middle, the value adding piece is where we might use interactive lectures or tutorials or group presentations. So the design of a particular unit occupies multiple processes, and these can be placed in different segments depending on the type of customer input. The design and choice of where you put these processes has an impact on the outcomes for the provider and to some degree the customer. First, the degree of control increases as you move towards independent processing, both for the provider and for the customer. The process is most inefficient in direct interaction and has the highest economies of scale when it's independent processing, and has the highest degree of customization when it's either surrogate or independent processing for the customer. And these surrogate positions here provide a trade-off or compromise area where we can actually achieve some economies of scale and some process efficiency. As we saw in the higher education example, we can place service processes in different domains. In this example here, we can see different competitive positions of service processes in the interaction designs they offer to customers. Here is a summary of the implications, and they particularly arise around customization, control, economies of scale, efficiency, and value propositions. Thank you for listening to my presentation. I hope you've enjoyed this very rapid discussion on service process.
Okay, this was a presentation of Mr. Steve Pierce, the last one presentation in this session. Does someone has a question for him? Mr. Pierce?
Yes, the only thing I'd like to add is this conference used to be run with direct interaction in previous years, and this year it's running with a combination of direct and surrogate interaction.
Yeah.
And consequently, the outcomes that we're seeing are slightly different. So the value add around direct interaction is lost, yet some efficiency perhaps in having videos available and to be able to watch those at different times as well, and in delivery. Obviously less resources were used as well. So just as the service design, this gives you an idea of when to design and when to use digital based on the sort of outcomes you want. So that's all I wanted to add.
Okay, well, this year is very specific. And this is also first time for us to organize something like this and in this manner. We tried to do our best, and we also made a small application. I gave you a shared link in a chat, and you can see all the presentations and all video materials there. And at the end of every presentation, there is a contact of the person that was in charge for presentations. So I know that the conference has that dimension of interactions with other participants. So in this moment, the email is the one of the possibility to start a conversation with other participants. Mr. Prokin, do you have something to ask or something to tell us at the end of the session?
Not for this session, but I will congratulate everybody having time to be on this session. I don't know for the others. Unfortunately, this year we couldn't enjoy Montenegro Coast, but there will be next year.
Okay. From my side, I also want to thank you all for the attention. I want to give a special thanks to all the people that were with me yesterday, so that are on the second day of the conference. And then I would like to remind you that in this room, we will continue session 14 at 15 o'clock. So you can stay with us or you can join us at 15 o'clock. Thank you all. Good day, everyone. Nemojte mi pušta muziku jer ljude ne čuju. Good day, everyone. Welcome to the session 14. It's a session DSP and artificial intelligence with applications. Today we have 7 presentations. The first presentation is by Mr. Conceptual Model of Hardware and Software Co-Design for Multi-Core on Chip. Do we have presenter here? Mr. Gregory Soldato.
Yes, I'm here.
Good day, Mr. Soldato. Welcome to the conference. Once more, you have a presentation on conceptual model of hardware and software co-design for multi-core systems on chip. Would you like me to show your video or you would like to do presentation by yourself?
Do you have my video? I sent it.
Yes, I have. Do you agree that we should first make a video and
yes.
After we will comment it? Okay, here it goes.
Good morning, good afternoon, and good evening to all conference participants. The paper Conceptual Model of Hardware and Software Co-Design for Multi-Core System on Chip suggests co-design of hardware and software of multi-core microprocessing structures for the cyber-physical systems, including Internet of Things. Outline of this presentation: problem definition, state of the art, methods, approach, results, conclusions. Problem definition. The purpose of co-design for multi-core systems on chip is to develop a conceptual model for such co-design for a multi-core computing system that will effectively implement all of the above processes and functions. Otherwise, the system will work ineffectively and the hardware will slow down the software, or vice versa. At the same time, the system as a whole must be monitored for integrity of its hardware and software systems with digital signature verification of trusted suppliers. The above processes and requirements should be taken into account in co-design of hardware and software. State of the art. At the moment, the creation of such systems implies the use of computer systems under the control of scalar processors. However, such processors, even considering modern capacities, do not allow to fully release the ability to accurately and quickly determine the necessary resource when designing the software or hardware of other systems. The main direction of these systems is to develop the software and hardware of such products that need to clearly and quickly cope with their tasks. Such systems include the detection of anthropogenic disasters, expert system for solving urgent problems, and etc. Methods approach. To solve the problem of quick and profitable interaction between system components, it was proposed to create a system that would allow manufacturers to tell which development path to take. As an example, which components to use to find a balance between performance and power consumption. What characteristics to the external impact should be in the equipment, and etc. The suggested co-design is based on formalization of one of the type models of knowledge, frames for decision of expert system on technical parameters. In experimental example is analysis. Methods of conceptual models based on frames. Frame as an image of the structure. The basis of a structure frame image is made up of the following slots: holes, the number of equivalence classes L, the order of equivalence classes, the type of data exchange between clusters within a class, the type of exchange of information between clusters of various classes, structure, speed, amount of frame memory, the number of microprocessor cores, and an additive function of the structure utility. In other words, we have a frame image. Classification of frame images. Fuzzy variable terms are used in a structure frame image, where K is pipeline structure, PK near pipeline structure, KV is pipeline vector structure, VKV near pipeline vector structure, MVK is matrix structure near vector pipeline structure, VK is vector pipeline structure, PV is near vector structure, and V vector structure. For exchange type 1 and exchange type 2, two concepts are used: sequential and parallel simulations. Classification of frame instance. As a result, the following frames instance are written for various structure like this on this slide. 32-bit Universal Control RISC processor ARM Cortex-A5, 4 clusters each containing an ARM Cortex-A5 RISC processor and 4 NMC4 processor cores. 5 interfaces with DDR3 external memory, interfaces PCI Express 2.0, SPI, Ethernet IEEE, GPIO, JTAG, high-speed interfaces for communication between processors. Conclusions. Development of new informational, operational and algorithmic support for multi-programmable cyber-physical system results in reduction of risk during decision-making in handling emergencies and using data from aerospace, ground and physical monitoring, analysis of problem dynamics and construction of forecast contours. Environmental conditions at the time of emergencies of natural or anthropogenic character are usually unstable or uncertain. Thus, using smart computer in processing of such data will increase efficiency of telecommunications in real time. Adaptation of the algorithm developed on the basis of narrow KS software complex for the software used in commercially available MS-127.05 modules will enable improvement and automation in gathering and processing of primary monitoring data. Thanks for watching.
Okay, this was a presentation of Mr. Soldato. Mr. Soldato, can you give us some more information about this, or would you like to share with us?
I can give a little bit information. First of all, the system development for developers to facilitate this task, namely to develop systems based on multi-core processors. A conceptual model has been developed that allows you to find the balance in systems between hardware and software, preventing one from slowing down one other. And in modern condition, it is becoming increasingly difficult for manufacturers to decision components and complex devices.
Okay, and I would like to know if you can explain us the usage of this system in natural disasters. How can this be used?
Sorry, can you repeat it?
At the end of your presentation, you mentioned that this could be used in natural disaster. So can you give us some more information about it?
In nature disaster, this can used by used by resource management resistance.
And is this research applicable for a market? Can it be used in a market? Have you considered your idea to be marketized maybe in the future?
In future, yes, but yet no.
No, okay. So this is some kind of a first stage research.
Yes, this is first stage, and I think we can do the good product, and he can help us to develop the better things.
Okay. Does anyone from other participants has a specific question for Mr. Soldato? No one? Okay. We have some presentations of convex optimization algorithms for sparse signals reconstruction, but I don't see any participants here. And moreover, it's a PDF, so I don't see any suitable model to show you that. Also, applications of Hermite function in image reconstruction and greedy reconstruction approaches to their applications of the compressive sensory signals and use of alternative direction method of multipliers in reconstruction of hyperspatial images. Those are the students' paper, and they didn't send us any video. So in that order, we will skip them. And we will continue with the paper of Nina Blagojevic, Milena Božović, and Tijana Radojčić. It's an iris recognition of images reconstructed with gradient-based algorithm. We have a video of it, and we will show it.
Greetings to everyone. The topic of this presentation is iris recognition on images reconstructed with gradient-based algorithm. In this presentation, we will talk about gradient-based algorithm and the iris recognition software we used, as well as the result of performing iris recognition on images reconstructed with gradient-based algorithm. Identifying humans based on their biological characteristics is predicted to be used more and more in the future, as it is considered to be the most reliable. One of those methods is iris recognition. Iris recognition is a procedure used for identifying persons based on unique patterns that are placed around pupils of the human eye. It uses high-resolution images of individuals' pupil and performs a pattern recognition technique on them. Our goal was to discuss possibilities of different iris recognition software to perform recognition on image that is intentionally damaged according to the compressive sensing. Missing image pixels are recovered using the gradient-based algorithm. The reconstruction is tested considering different percentage of the pixels as damaged. We focused on comparing the two different iris recognition software, VeriEye and Girist. Compressive sensing is lately used more in comparison to traditional Shannon-Nyquist sampling theory, as it provides a good quality of reconstructed signal with smaller amount of samples. Compressive sensing allows reducing the number of samples at a great extent if certain conditions are satisfied. In addition to that, reduction in procedure time is achieved due to simultaneous receiving and compressing the signal, which helps in decreasing the waste of resources. However, as I mentioned before, this approach can be applied only if the two important requirements are fulfilled. First of them is sparsity of signal. It represents the possibility to present the signal with small amount of non-zero samples in certain domain. Second requirement is incoherence between measurement metrics and sparsity basis. This means that signal has sparse representation in the transform domain, but is dense in the domain where the acquisition is performed. Higher incoherence lowers the number of non-zero samples used in the reconstruction process. Successful signal reconstruction requires the use of optimization algorithms that allow the signal to be reconstructed from a small set of available samples. In this paper, we focused on gradient-based algorithm for reconstructing missing samples. Gradient-based algorithm provides good reconstruction accuracy using a relatively small number of signal samples. In this paper, we use 2D discrete cosine transformation, or DCT, as a sparsifying basis. This algorithm does not require sparsity condition, which eases its applicability in real applications. Gradient-based algorithm is popular when solving unconstrained optimization problems. By exploiting knowledge of the gradient of the objective function to optimize, each iteration of a gradient-based algorithm aims at approaching the minimizer of said function. As I said in the beginning, we use two software for testing iris recognition on images that are firstly degraded and then reconstructed by using compressive sensing. First of them is VeriEye. It is created in 2008. This software is capable of detecting the inner and outer boundaries of the iris of one single image, as well as comparing multiple images. When comparing two images, it tells us if those images are a match. In our case, we are comparing the original image without noise, with the reconstructed image with specified percent of noise, trying to determine the highest amount of noise applied on the image for which software can still match it to the original. It is capable of dealing with different kinds of obstructions, like non-perfect circular shape of iris, narrowed eyelids, eyelashes, and it takes less than half a second to process an image of the human eye. The other software we use is Girist. This software is created by GrooveSoft. It calculates the Hamming distance between two images. The Hamming distance between two objects represents the amount of samples in which those two objects differ. The threshold value for the Hamming distance here is 0.36, and it is experimentally determined. This means that every pair of images whose Hamming distance is more than 0.36 are not a match. Girist has three modes. The first one is iris authentication, or one-to-one matching, which distinguishes whether they come from the same person. The second one is iris library verification, or many-to-many matching, which is used to make sure the library is reliable and usable. And the last one is iris identification, or one-to-many matching, used for finding a person's identity from a library. Our goal was to perform iris recognition on images reconstructed using gradient algorithm. We were using code for gradient algorithm written in MATLAB to reconstruct images of human pupil with different level of noise. Using the MATLAB code consisted of setting the parameter that defines the percentage of the missing samples. Then, DCT of an image is calculated by using 16 by 16 blocks. In the end, we reconstructed the image and calculated the signal-to-noise ratio, or PSNR. We noticed that the signal-to-noise ratio decreases with increasing of noise. The first software I will talk about is VeriEye 11.2. In this picture, you can see the image reconstructed with gradient algorithm for different percentage of missing samples. As you can see, for images with percentage of noise less than 70, decreasing quality is not quite noticeable. For the values of missing samples percentage over 90, the distinctive decrease in quality is obvious. However, the software was still able to detect inner and outer border of the pupil, even for image with 99% of missing samples. On the other hand, software could not match reconstructed images with over 95% of missing samples with the original. The VariEye also reports a parameter called match score. This parameter can have values between 0 and 3235, and it represents the level to which the two images match. In other words, higher match score indicate better match. In the cases in which reported score is less than 49, the software reports failure in matching. Another iris recognition software we used is Girist. It takes two images and compares them to determine if they come from the same eye. Girist has the ability to detect inner and outer boundaries of human pupil as well. In this picture, the comparison of the original image and the reconstructed image with 30% of missing samples using Girist is demonstrated. Since the difference between those images is small, the software recognizes boundaries of pupil on both images identically. The Hamming distance in this case is 0.0704, meaning that the software matched those images. This picture also shows the comparison of reconstructed images with 60 and 90% of missing samples with the original image. As in previous case, the software recognized the irises and matched reconstructed images with the original. The analysis showed that starting from the 95% of zero-valued samples, the software reports that the process of matching have failed. For this parameter, Girist and VariEye gave exactly the same result. On the other hand, the two software didn't give compatible results when it comes to marking the boundaries of pupil. Here you can see that for image with 99% of noise, Girist was not able to correctly identify the outer border. In this picture, you can see that values of the match score gradually decline with increasing the noise, while Hamming distance mostly increases. As the analysis of previously mentioned parameters was done on one picture, the results varied. The two software give pretty similar results when it comes to quality of iris recognition. Both software were able to match image with up to 95% of missing samples with its original. Also, the ability to correctly detect boundaries of iris is very high on both software, 99% on VariEye and 98% of Girist. These statistics show pretty high degree of reliability of those software. Thank you for your attention. If you have any questions, do not hesitate to contact me at my email address.
Okay, this was a presentation of Ms. Blagojevic. I don't see anyone from this group of authors present. So we will continue with the next paper. It's testing of sparse domains and gradient-based reconstruction algorithms on 1D biomedical signals. It's a paper of Ognin Bošković, Ana Nišević, and Jelena Stanić. They are also not present, but they have sent us a video, so we will broadcast their video.
Hello everyone. Our theme is testing of sparse domains and gradient-based reconstruction algorithm on 1D biomedical signals. The main interest is concept of compressive sensing and its application in 1D biomedical signals. The accent is on analyzing several types of biomedical signals and finding the domain in which they are sparse. Compressive sensing is an approach that allows us to overcome the limitations of traditional Shannon-Nyquist sampling theorem. There are a couple of requirements that need to be fulfilled in order for reconstruction to be successful: sparsity and incoherence. Sparse signal is a signal that has a large amount of energy stored within a small number of samples. Incoherence means that signal having sparse representation in certain bases must be spread out in the domain in which we measure them. Number of available samples that we use is fewer than the number of samples that we are trying to reconstruct. Reconstruction can also be done using norm minimization algorithms, and nowadays more commonly using gradient threshold-based algorithms. Our main point of interest are ECG, EEG, and EMG signal, and these signals are observed in DFT and DCT domains because of their common use.
There are a couple of requirements that need to be met in order for compressive sensing to be feasible. Firstly, the signal needs to be sparse. Most of the natural signals are sparse when transformed in a certain domain. Secondly, basis of that transformation must be in coherent measurement matrix. We can assure this by taking our measurements randomly. That way, our measurement matrix is random and as such is incoherent with any other matrix. To reconstruct the original signal from the compressed signal, we need the x from the equation. The problem is that the system of equations is undetermined and can't be solved easily. A number of algorithms has been proposed. One of them, and the one we used for our research, is adaptive gradient-based algorithm. In this method, we assume that missing samples have zero initial value. Iteratively, value of missing samples is changed for a positive and a negative value of appropriately chosen step. Goal is to achieve minimum of L1 norm. Therefore, gradient vector is calculated as the difference between L1 norms calculated for positive and negative step, and used to update values of missing samples. As the missing samples values converge, gradient changes less and less, and we reduce step value in order to approach to the stationary state. Algorithm stops when we achieve the desired precision or step value falls under a certain threshold.
Telemedicine enables medical professionals to use telecommunications technology in evaluating, diagnosing, and treating patients at a distance. Typical example of telemedicine is Body Area Network, or BAN. A BAN or a WBAN, which stands for the Wireless Body Area Network, is a wireless network of wearable computing devices. These devices may be placed inside of the human body or on the surface of the human body in a particular position. They are paired with nearby smartphones or handheld devices with GPS capabilities to communicate with the doctor via the internet. Amount of data that needs to be transmitted is proportional to the number of devices connected to the BAN. The aim is to have as many devices integrated in the BAN so medical diagnostics could be done with ease. Hence, in order to reduce energy consumption, we use compressive sensing. For electrocardiography signals or ECG signals, compression factors up to 16 times can be achieved. ECG signals are submissive to compression because of their structure, specifically low activity regions between QRS complexes. Electroencephalogram signals or EEG signals are collected over multiple channels and with multiple trails, resulting in large amount of data that needs to be processed and stored. The EEG signal sparsity in a Gabor frame is utilized for compressed sensing. For a measurement matrix F, independent and identically distributed Gaussian basis is used. It is also shown that EEG signals can be processed and compressed jointly rather than separately, which is handy since these signals are usually recorded over multiple trails and electrodes. We took 3 types of biomedical signals for testing: EEG, ECG, and EMG. We reconstructed them using algorithm mentioned before and tried using both DFT and DCT domain. However, DFT domain has shown much better results. Comparison of DCT and DFT mean squared error is shown in the pictures. Ratio of absolute error to the absolute value of the original signal is used to estimate the precision of the reconstruction. Presented with this formula, P is obtained precision in decibels. Less decibels means higher precision. Generally, good precision is considered under -20 decibels. In telemedicine, even lower quality is acceptable. Results obtained for different level of sparsity are shown in the table on this slide. Reconstruction of different 1D biomedical signals with 40% available samples is shown in the pictures. In the end, on the behalf of all of us, I would like to thank you for your attention.
So this was a presentation regarding testing of sparse domains. I regret that we have not any participants from the last two presentations. The topics were very interesting, and I regret that we cannot obtain a feedback from them. So once more, I would like to ask you all if you have any question to Mr. Soldatov, or does he has anything else to add regarding his research and his paper. Mr. Soldatov? Okay, if you don't have any questions, I need to conclude this session. I remind you that in this moment, there are also two active sessions, sessions 17 in room 2 and session 20 in room 3. There are a lot of interesting topics there, and you can join those sessions until 18 o'clock when we'll be starting our last session for today, session 15. Thank you all. Good day to everyone. We will start our last session for today in 2 minutes.
Yeah, good day.
которые придерживаются сейчас республиканцев. Значит, они рассадили во всех государственных структурах и силовых структурах Соединенных Штатов своих сторонников. И
So, once more, good day to everyone. Welcome to the session 15 of section 4, DSP and Artificial Intelligence with Applications. The session chair is Mr. Alexander Mursaev. I think that he will join us later because I saw him in a last session. In this session, we have 6 presentations. The first one is from Alexander Mursaev, and we will postpone it for a little bit later. The second one is, let's just, Vladimir. Okay, we have here Mr. Vladimir Volkov. Good day, Mr. Vladimir. We have here your presentation, the detection and extraction of objects of digital images. Okay, you can unmute yourself, or I will.
May I start?
Yes, yes. We are waiting for you.
Okay.
Share your screen or whatever is suitable for you.
Can you see the title?
Not yet.
I can see my presentation at my screen.
Can you press in the bottom side? There is a share screen button. 6th button from the left.
With green color.
With green color, share screen.
Yes, I try.
Okay. I have your presentation here, but it's difficult to broadcast it because it's rotated. So
and where is my presentation in this?
Vladimir Volkov,
yes.
I have your presentation here, but last time I saw it, detection of objects, it was rotated, yes. Something like this. I'll show you now. And that's, okay, just a second.
Yes, but
yes,
it's oriented, bad orientation.
Yeah, it has a, I will just...
May I...
sorry, just, okay, that's good. If you want...
Excuse me. Maybe I can say on Russian to my colleague Vladimir Volkov.
Okay.
Yeah. Владимир, там внизу есть зеленая кнопочка,
Да.
green color. Вот ее
Да,
нужно
да, да.
нажать, и там у вас должен...
И пишет, что не можете включить, поскольку демонстрация экрана осуществляет другой участник. Видимо, там...
да, я, наверное, понял.
Ну вот. Да. Но сейчас я ее вижу, презентацию свою.
Excuse me, I think the problem because Vladimir can't share screen because it's maybe restricted on your side.
It's allowed by my side, but if it's better, he can tell me next, and then I will pass to the other slides. So I can do this, and then he said the next, and I'll do this.
Окей. Владимир, попробуйте просто тогда говорить презентацию и просто, когда
Вот
там
то,
следующий слайд, говорит next.
То, что на экране, это видно? Это видно?
Да, это видно.
Это видно. Okay.
Да.
My presentation has title Detection and Extraction of Objects in Digital Images. Next, please. I am Vladimir Volkov from St. Petersburg, Electrotechnical University, and my co-author is at the same university, and we present this topic. The next slide, please. The problem addresses to the images from remote sensing and some medical images which contain compact and isolated objects on the background of the other type. There are some examples of remote sensing and biomedical slides where we can see bacteria which are compact and isolated as well. The next slide, please. Okay. This is another examples of remote sensing. The airplanes and the boats which are on the background. And the task is to extract these objects and localize them and maybe evaluate some parameters. Next slide, please. There are three main directions of segmentation problem because the general segmentation problem is correspond to the more task, and my task is more special. There are three main directions. Thresholding is a simple procedure, the edge counter segmentation, and the cluster growing. I will report about the threshold segmentation, which may be histogram-based, adaptive local thresholding, and adaptive multi-threshold. This object selection, which will be the proposed algorithm. Please, next. Our method is simply the first converting image to the set of binary slices. When each slices is is processing with restriction of the object's geometric parameters when the algorithm creates a three-dimensional hierarchical structure where the third dimension is the threshold. And the final step is selecting objects and choose the slice where the object have the desired properties. Thank you. Next slide, please. Method which we consider is based on the percolation effect. Percolation effect appears when we increase threshold and some initial object will be the whole image, and when objects losses their areas, and you can see some object with contain two parts, and when after threshold is raised, the object is fragmented to the two parts, and when the second part is disappears. The percolation effect allows us to define the life of time of the object when the threshold is growing. So the three-dimensional structure contains objects as the volumes in the three-dimensional hierarchical structure. Okay, please, next slide. These are characteristics of the two objects. We can see the points of percolation when the one object is fragmented to the two parts. And we insert some coefficient or the rate index which shows the speed of decreasing the areas of objects at every step. So this parameter is one of the parameters of the algorithm. Okay, next slide. There are some geometrical criteria for object selection, which shows the compactness of object. First criteria is the object area, and the second two are some coefficients of perimeter elongation and relative elongation of the main axis of the ellipse. These parameters allows us to adapt algorithm to the desired geometrical characters of the objects. Okay. This next slide, please. You can see the result of processing of the test image, the Gaussian background, and 49 objects of the squared shape, and this is the result of this selection of this object. We compare this to the two famous algorithms. The first is the Otso threshold, the adaptive global threshold, and the second is the Bradley-Roth threshold, which is adaptive local threshold. Please, next slide. The next slide, please.
It goes a little bit slower.
Yes, this is the...
I move it, and then a few seconds after it shows on the screen.
I start to finish.
Okay.
This is the result of the Neyman-Pearson threshold and the Otso threshold. The next slide, please. I want to show real images. these are the characteristics of these algorithms. The detection characteristics and when and next slide, please. The very bad. I can't. This is the dependence of the false alarm probability from the minimal area of objects, and this graphics shows that we can use the less threshold than the classical one. Okay, the next slide. This is the characteristic of the selection, which are dependent on the percolation coefficient of the relative perimeter elongation of the object, and you can see the same property, but we can use the less thresholds, so we can raise the effectiveness of detection. Okay, the next slide. These are real aerial image and the result of object selection. The bottom graphics show the values of adaptive threshold, and the right graphics show the U-shaped curve, which allows to set the optimal threshold. Thank you. The next slide. And the next. Yes, these are the we compare the results of selection with the two algorithms, adaptive algorithms, the Otto threshold and the Bradley-Roth threshold. And you can see the advantage of the adaptive selection with multi-threshold processing. The next slide, please. These are qualitative comparing of the characteristics, the recall precision curve, and the receiver operating characteristics. And this point is the Bradley-Roth algorithm, and this point is the proposed multi-threshold adaptive algorithm. And you can see the more the precision and the slightly less, the more recall and slightly less precision. Okay, the next slide. That's all. The conclusions, which shows some advantage of the proposed multi-threshold adaptive algorithm with object selection after processing. Okay, thank you. This is the last.
Yes, this is the last one.
Thank you.
So the signal is a little bit late. So I'm switching the slides, but you can't see it in the same moment as I do. But the most important thing is that we have finished it successfully. It was a very interesting theme. And I would ask other participants if they have some kind of a question for you.
Are there any questions? Maybe it was clear.
It was clear. And do you have something else to tell us? Something else to add to this presentation? Something else to share with us regarding this research?
Yes. I want to say that this is some new elements because the algorithm works after thresholding, not before, as the two famous adaptive thresholdings. It uses the results of thresholding, not the properties of the initial image. This is the main advantage because we can see the results and we can change some characteristics to vary properties of the algorithm.
Okay, and do you plan further research regarding this topic?
Yes, this is the project which supported the Russian scientific fund, and I hope it will have some new results and maybe some useful applications.
Yes, some kind of a tangible outcome.
Yes, outcome. Okay.
Okay.
Sorry, because we practice very little at this moment.
Okay. Thank you, Mr. Volkov. If no one has a question for Mr. Volkov, we can continue with other presentation. Yes. Here I see Mr. Valery. And I think that he is in charge for segmentation-based vehicle tracker for real-time parameter estimation on smart camera. Am I right? Mr. Valery?
No, I'm listening.
Okay, so it isn't your presentation. Segmentation-based vehicle tracker. Well, in this session, we have almost 6 presentations, and I don't see all participants in the group. So I propose to broadcast videos of some presentations and to wait until the end of the session for authors if they join us to comment to their research. Is it okay for all of you? Okay, we will start with the first presentation, hardware implementation of compressed data packing by Mr. Alexander Marsaev. Here it goes.
Ladies and gentlemen, my name is Alexander Marsaev. I am from St. Petersburg Electrotechnical University. Topic of my report is hardware implementation of compressed data packing. Data compression is one of the important procedures used for storing and transmitting large data sets. Compression increases speeds of exchange between remote or local sources and receivers. In this article, we will focus on lossless compression used for transmitting blocks that consist of an arbitrary sequence of characters from a limited set, half-wave encoding as example. The general feature of this algorithm is the transformation of original stream of equal length symbol into stream of variable length data units, compression equivalent symbols, CAS. But really, effect is achieved if CAS are closely packed. For remote communication, the bits of adjacent sets are transmitted directly one by one without blank. For writing to inner memory, the converted data is packed without blank into a sequence of words of its chosen length. For both cases are discussed in the report. The packing algorithms are well known, and their implementation in the programmable processor core is relatively simple. However, the software execution of this operation does not satisfy demands of conversion speed. Hardware support effectively eliminates the time spent on generating and packing a test sequence. Cost of hardware implementation is minimal. Such device can be implemented into programmable logical chip connected to the processor core, for example, in coprocessor architecture, or directly embedded into programmable system on a chip. Conversion and packing into bit sequence is relatively simple. A small memory that stores encoding table needed. Each cell corresponds to an original symbol and consists cis and its length. At the beginning and after transmission of some symbol, cis corresponding a next one is written to the shift register and length is written to the counter. At each clock, counter is decremented and next bit is sent to output. When counter is zeroed, process is repeated. Main program for the receiver is detection of code borders. It is done solving a decision tree. For bit sequential presentation, we used memory-based state machine. Each node of the decision tree is presented by a memory cell. When auxiliary node is executed, one of successors is selected dependent on current bit, and its number is loaded to the state register. When a leaf node accessed, the state register is returned to initial state. If a new word of compressed sequence may be placed into buffer, it is written closely after previous one. Else, only lower part of code is written to the buffer, while remainder is delayed, and after reading and clearing buffer, these remaining bits are written to the lower bits of buffer. Decoding is also realized by traveling through decision tree, but sequential bit-by-bit analysis is time-consuming. Next slide shows structural realization of the decision tree solving. Here all bits are analyzed immediately due to space sharing of operation. When CES comes to input, the path from root node to corresponding leaf is activated. Leaf node is an immediate entry to the hot memory. CES length and the original code of corresponding symbol appear at the memory output. The additional problem is the necessity to provide coincidence of cis and that are arbitrarily located in word sequence with the input of decision tree solving unit. The process is illustrated on the next slide. At each step, contents of buffer is shifted due to the length of very right chess, and if the shift spares enough place to insert new input word, this word is copied to the vacant part of the buffer. Algorithm presented in this article can be easily translated into one of the design languages, VHDL or Verilog, and then compilation and implementation to the touch chip if performed. Device packing transforms symbol into sequence of word is rather complex, but for example, only 1,000 equivalent gates are needed to implement the unpacking decoder of 8-bit original symbol presentation, 16-bit minimal syslength, and 16-bit words to store packed sequence. That's all. Thank you for the attention. Thank you.
So this was a presentation of Alexander Mersaev. Our next presentation is segmentation-based vehicle tracker for real-time parameter estimation on smart camera by Maxim Ershov, Sergey Smirnov, and Valery Stronov. Do we have authors here? So in that order, I will also start their video.
Good day, dear colleagues. My name is Maxim Yershov. I am from Russia, Ryazan State Radio Engineering University, named after V.F. Utkin. I would like to introduce the segmentation-based vehicle tracker for real-time parameter estimation on smart camera. You can see the presentation outline. We start from problem definition. After that, I will describe the proposed embedded solution. After that, I present developed video processing algorithm in short. At the end, I will show some results of experimental research and finally summarize the work. Due to a growing number of problematic road intersections, huge resources are needed to monitor the situation and organize traffic. Transport analytics system is one of the most important components of any intelligent transport system. At the same time, technical vision and data processing algorithms play an important role. It is proposed to build a transport analytics system using smart cameras, which are installed on the busy road sections. These cameras are connected to the traffic control center. The problems of processing the entire amount of video data are transferred to the smart camera platform. To estimate traffic flow parameters, we must perform vehicle detection, its speed and size estimation. The solution of these tasks is initially performed by the algorithm described in previous work. You can see the summary of this algorithm. The algorithm is based on marking of areas of interest in the image, so each road lane has its own lane region of interest, called sensor. Each area is divided into a zone of entry Z1 and the zone of exit Z2. On first stage, the algorithm performs the background estimation in each of the sensor zones. The second stage is extraction of segments that differ from background. The algorithm divides the points into 4 categories: object, background, shadow, and highlight. After object detection, we can estimate its parameters and calculate traffic flow parameters. The Bayes algorithm shows high quality of solving vehicle detection and counting problems, but the accuracy of speed and size estimation is not good enough because it is possible to calculate vehicle parameters only on moments when vehicle entering or leaving the zones. In current work, we present algorithm for tracking object segments on binary image. Tracking algorithm estimates the interframe displacement of object segments in order to improve the accuracy of parameter estimation. Here is the summary of the described algorithm. The vehicle segment tracking algorithm starts from the frame when the Bayes algorithm detects the entry to Z1 zone. The algorithm's input data are binary images for zones Z1 and Z2 obtained at the segmentation stage in the Bayes algorithm. So we have initialization stage and main stage that include tracking object during moving through the Z1 zone and when during moving through zones Z1 and Z2. After that, we can calculate vehicle parameters. The algorithm is affected by the segmentation quality. An important part of segmentation is to get the difference between the current frame and the background. Segmentation of the difference image has issues because important color information is lost. For segmentation quality improvement, we use images in YUV color space. On each frame, we perform post-processing of segmentation results. For this purpose, we use morphology, parametric filtering, and contour extraction. Parametric filtering includes combining all segments whose number of points is greater than specified threshold. Contour extraction allows us to further reduce computational costs because the number of points under consideration decreases. Here is the example of segment tracking process. So we estimate the interframe displacement of object segments by calculation of the distance between the object and the entry line to Z1 and distance between the object and the exit line from Z2. The research included evaluation and comparing the performance of the Bayes vehicle detection algorithm and the proposed algorithm that is using segment tracking. 3 classes of vehicles were considered for classification: passenger cars, medium cargo and passenger cars, large cargo and passenger cars. The research was performed on video base collected using video cameras that observe different sections of roads. Also, the GRAM and CDNet databases were used. You can see images from videos. Green frames indicate the sensor for each road lane. This is our base. Video from GRAM database and video from CDNet database. The table contains generalized results of experimental studies of the Bayes algorithm in comparison with the results obtained using the proposed tracking algorithm. The following metrics are presented in the table: percentage of correctly detected objects, percentage of type 1 errors, percentage of type 2 errors, and percentage of classification errors. So I'd like to summarize our work. Base vehicle detection algorithm allows detecting 91% of vehicles. The percentage of errors was about 10%, and the percentage of classification errors was 16%. Segment tracking algorithm increased the number of correctly detected objects by about 5%, while reducing the number of errors by 6%. Also, the probability of classification errors was reduced by 7%. Thank you for your attention.
So this was a presentation of Mr. Eshel. As I see, we don't have anyone from his team here, and we will continue with a presentation called Embedded Image Processing and Video Analysis in Intelligent Camera-Based Vision System. Do we have anyone here from that group of authors? Mr. Boris Alpatov, Pavel Babayan, and Maxim D. Ershel. In that order, I will also broadcast their video to the conference. So we have a, okay. Here it is.
Good day, dear colleagues. My name is Maxim Yershov. I'm from Russia, Ryazan State Radio Engineering University, named after V.F. Utkin. I would like to present you a work on the topic Embedded Image Processing and Video Analysis in Intelligent Camera-Based Vision System. You can see the presentation outline. We start from problem definition. After that, I will describe a video analysis system. After that, I present technical specifications of embedded platform. At the end, I will show some results of measurement of algorithm execution time on different platforms, and finally summarize the work. For effective traffic management in the city, there is a need to monitor a large number of road intersections. The solution is to install CCTV cameras. However, communication channels are required for the transfer of large amounts of data and further processing using computer centers. Using intelligent camera can reduce the requirements for communication channels. There arises the task of developing algorithms that should work under various difficult conditions, but the computational capabilities of cameras are limited. The structure of video analysis system is presented on this slide. Embedded online video processing reduces the amount of data transmitted to the traffic control center. Consequently, the requirements to communication channels and the computing server are reduced. In our work, access products with the possibility of embedded video processing are considered as the platform for implementing algorithms. An essential feature that must be taken into account when developing algorithms is the limited computing resources of the target platform. The main problem is the computational complexity of a particular algorithm. However, the efficiency can be improved if we take into account the features of the target embedded system. Most of the devices provided for research and testing of the developed algorithms have ARTPC chips. The ARTPC chips consists of the following parts: capture image processor, video encoder, general purpose processor. Only last processor is intended for additional tasks as well as for applications developed for smart camera. ARTPC5 has larger cache size and high memory bandwidth compared to the ARTPC4. Also, its center processing unit has two multi-threaded cores. Main advantage of ARM version 7 based chip is floating point unit. In this table, you can see frame capture time measurement results. So, ARM based chip has an advantage over others. This slide presents features of comparison of the time taken to process one frame by different implementations of the algorithm for detection of moving vehicles. Intelligent cameras with different processors are used. Observation was carried out for one of 4 lanes of the road. Each lane has its own processing area, so frame processing time was measured without and with parallel processing of lanes in threads. The base algorithm is the algorithm for detection of moving objects and estimation its parameters without using tracking. This algorithm always works with a full-scale image. For the tracking algorithm based on the optical flow, the processing time for different scales was also measured. In the time column, 2 time values in milliseconds are presented through a semicolon. The average processing time for frames on which there is no movement and average processing time for frames with moving vehicle. As can be seen from the table, the application of the tracking algorithm based on the optical flow, even with a small number of points, is impractical on processors of the ARTPC family due to the lack of floating point unit. This slide presents features of execution time measurement for stopped vehicle detection algorithm. This algorithm can process a color image. Image resolution reduction is used to reduce computational costs. Stopped vehicle detection algorithm processes the entire image and is based on queue of background estimations at different small time intervals. There are no floating point calculations in this algorithm. However, the ARM-based chip still has an advantage. So I'd like to summarize our work. It is recommended to use devices based on more powerful processors with floating point unit. If the system does not have FPU, then it is advisable to refuse floating point arithmetic or use fixed point arithmetic. Second option to speed up computations is to use parallel computations on multi-core processor. Third option is universal and consists in reducing the resolution of a processed image over processed image region. Thank you for your attention.
Okay, this was a presentation of Mr. Erschel. Our next presentation is synthesis of the method of operative image analysis based on metadata and methods of searching for embedded images. This paper is done by Ms. Rosa Faktieva, Shikina, and Tishenko. Do we have anyone here from this group of authors? If no, I will also share their video.
Good day. My name is Shikina Julia. I am from St. Petersburg Electrotechnical University. Let me present my report by topic: synthesis of the method of operative image analysis based on metadata and methods of searching for embedded images. In the digital age, image, due to the ease of their receipt, distribution, and storage, becomes the main source of information. With the development of image editing programs, there is no need to be an expert to make changes to photo content. Development trends show that the peak of popularity of research on the search for embedded images dates back to 2016. In recent times, it has been possible to observe a decrease in the number of studies due to the formation of new field of digital forensics. Research in this area allows to estimate the percent of crimes in various fields using image modification. The main methods for identifying embedded images are image analysis, determination of the level of its compression and noise, which allow to find built-in element, deformation and cloning of objects. Methods for assessing confidence in image are beginning to develop rapidly, including with the implementation of automatic confidence assessment using various programs. In developing our approach to assessing image confidence, we analyze the following existing methods for finding embedded images: error level analysis (LA), noise level analysis (NLA), principal component analysis (PCA), metadata analysis (EXIF), and clone detection. We saw that at present there are no resources in the public domain with an automated assessment of confidence. Today, the user makes the decision on confidence they made by studying and comparing the result of various methods. This is difficult for user who is not an expert in the field of confidence assessment methods. The developed mobile application consists of a combination of two types of system: an embedded image detection system and a confidence assessment system. To search for embedded images, we used a synthesis of two methods: ELA, error level analysis, and NLA, noise level analysis. This makes it possible to calculate the absolute difference between the original image and the compressed one, find the medians for each image pixel, and calculate the noise level deviation matrix from the original image. Next, we analyze the image by its metadata. The combination of these methods allows the calculation of confidence estimators. The main function of the ELA method is to calculate the absolute difference between the original image and the compressed one. To do this, we get the image parameters. These parameters can be set by use or be set by default. Next, we compress the image to be required level using the JPEG algorithms. The next step is to calculate a matrix of the absolute difference between the pixels of the original and the compressed images. The final step is to convert the image to a black and white image. The application of the ELA method allows to determine whether the image has been digitally modified and proceed to the assessment of confidence using the NLA method. The NLA method is based on the search for the deviation medians of each image pixel and the calculation of the deviation matrix. The first step of the NLA algorithm is to obtain the size of the aperture of pixels within a square of size L by L around a given pixel. This allows to find the median deviation for each pixel in the image. To do this, we construct a sorted variational series from the pixel aperture. Then we find its midpoint. Then we construct the deviation matrix from the result of the original matrix and the median matrix. The NLA method allows to identify areas that have been modified, taking into account the possible noise of the image received from the camera matrix. The main stage of confidence assessment finding a threshold of values, comparing the background of block with a threshold, counting the number of blocks outside the thresholds and analyzing image information. This allows to calculate the estimate of confidence. The result of the algorithm is an integrated confidence assessment by metadata, and counting the number of blocks of artifacts. To form an assessment of confidence in the image, we take the result of the ELA and NLA methods. For each method, we calculate the threshold pixel value of the black and white image matrix, taking into account the background and standard deviation for each block. Compare it with the threshold and count the number of artifact blocks that exceed the threshold. Blocks artifacts of embedded image are marked in red. If it is necessary to obtain an integrated assessment to calculate the total number of blocks of artifacts, the results of the method are combined. The image is analyzed separately according to its metadata. File type, vertical size, horizontal size, compression level, camera model, orientation, frame encoding code, last modified date, last program launching, shooting date and time, and compare it with the values obtained from the other method. The use of combination of estimation methods improve the accuracy of the search for embedded images. The developed mobile application allow to upload an image, calculate the image confidence rating, check the image using one of the methods or their combination. An example of the automated evaluation of embedded images is shown on this slide. Here you can see the integrate % confidence rating. The application tabs contain information about the number of artifact blocks that were found and the status of metadata. To evaluate the application, we tested images with modifications. We calculated the % of false alarm and missed goal. We use the method of integrated assessment of confidence and each method separately. As a result, The average percent error of the first type was 8.8 and the second 2.85. An integrated approach of the two methods allows to reduce the percent of the errors of the second type. The increase in the percent of error of the first type is due to the fact that then setting an integrated assessment of confidence, the number of false alarms increases. This is due to the combination of identified modified image blocks in each method. Based on the test result, we can conclude that the automated assessment of confidence in most cases exceeds the visual assessment performed by the user. The methods presented in this work can be used in the field of forensic science, journalism, and science to detect embedded images. For further research, it is necessary to develop methods for analyzing the noise level and analysis of the main components, which will allow to establish the most accurate assessment of the reliability of the image. This is end of my report. Thank you for your attention. Goodbye.
This was a presentation of Miss Rosa Faktieva. The next presentation is a miniature indirect conversion X-ray detector with efficient noise filtering techniques. This presentation is done by Evgeny Garshev, Alexei Minoshkin, Andrei Trubushkin, and Andrei Fefelov. We do not have them here in the session, so in that order, I will also start their video.
Good day. My name is Andrei Trubitsyn. I am professor of Ryazan State Radio Engineering University. My presentation: a miniature indirect conversion X-ray detector with efficient noise filtering techniques. The theme of my presentation is standard problem definition, state of the arts, methods, results, conclusions. X-ray microscopy and microcomputer tomography are relatively new research methods. The objectives of the X-ray research include microelectronic devices, biological and small-sized medical samples, various engineering products and art objects, geological samples, etc. The purpose of this research is to development an image recording system for miniature X-ray microtomography equipment used in the high-resolution analysis of small objects. One of the main technical units defining advantages of digital X-ray equipment is an X-ray image detector. The detectors offered today for scientific research use technologies of both direct and indirect conversion of X-ray radiation into electric signal. Detectors using direct conversion technology are difficult to manufacture and they have a small work area and a higher cost. The most commonly used today detectors are indirect conversion detectors. Such detector consists of scintillator and image reader, CCD or OS or TFT matrix, and can be classified as follows. large format digital detector, flat panels detectors, FPD, and miniature digital detectors based on input optics. For example, lenses or fiber optical taper conjugated with CCD or CMOS camera. The resolution of the second type of detectors is 5 times better, and they are not too expensive. We want to build in our laboratory an inexpensive microcomputer tomography system with a resolution level sufficient to solve the most up-to-date problem. Here, the design of a miniature indirect convection detector is presented. The detectors consist of fiber optic taper float and a CMOS camera. The float is fixed directly to matrix of sensors. To convert X-ray radiation into visible light, a phosphor screen is placed at the input of the phot. The detector, the main advantage of phot detector is the high quality of image transmission to the CMOS sensor in the absence of light loss. As part of the work to expand the functionality of the in-house software package X-ray Projection Pro, I've presented the features of this software at the last MECO conference. At first, in this direction, an image capture model was developed, C++, to control the operation of the Basler CMOS camera. The module allows you to set the region of interest, the time of exposure parameter, the image brightness, the pixel data. The module has user-friendly interface and allows you to optimally configure the shooting parameters. Secondly, new switching filter of impulse noise is proposed. Switching filters are one of the types of adapter filters. The switching median filter process consists of 2 steps. At the first step, image pixel corrupted by impulse noise are detected, and then such pixels are corrected by a standard median filter. The detection algorithm proposed in the work is based on the analysis of intensity increment in the current pixel at location ij relative to the immediate neighbors. It is shown that the proposed method is suitable for eliminating not only a single pixel but also multi-pixel impulse noise appearing on images as a result of various physical effects. It is found that to suppress single pixel noise impulses s equals 1 by 3-on-3 median filter, the parameter gamma must be exceed the threshold gamma 1. Gamma 1 for simultaneous suppressions of 2 pixel and single pixel impulses. The condition gamma equaled gamma 2 must be fulfilled. In this work, it is shown that to exclude the impulses with s more than 4, there is no need to further reduce the value of gamma below the threshold gamma 4. In particular, to eliminate non-pixel impulses, it is enough 3 iterations of image processing with the following threshold values. The first iteration with gamma equals gamma 4, second iteration also with gamma 4, and third iteration, last iteration, with threshold gamma 1. Next slide presented the result of suppression of multi-pixel impulses noise in the real X-ray microchip image. Slide shows the original image with a marked multi-pixel impulse. Upper figure shows a structure of the multi-pixel impulse. The impulse in the image corresponds to a search in the intensity profile. Proposed method suppresses impulse noise and just a little reduces Gaussian noise. For comparison, two images processed by standard median filter and one of the best well-known switching filter based on the dispersion measurement called mode are demonstrated. It's a standard median filter reduces search, but also it greatly reduces Gaussian noise, and therefore leads to blurring of the image. Mode is really a good filter. It reduces in 2 times the search of intensity profile and practically does not reduce the Gaussian noise. Table 1 presents quantitative test scores. The new filter proposed standard median, they commonly used 1 and they often quoted 2, and the best filter from review 3 are compiled through 2 parameters P. The first parameter is relative number of the noise impulses after processing. The second parameter is the relative standard deviation of intensity profile. The closer this parameter to 100%, the less Gaussian noise can be suppressed, which means that fine details of image have been better preserved. Analysis of the table data shows that proposed new method is outside from competition in the first parameter. The filters 2 and 3 and proposed one supply practically the same value of second parameters. Conclusions: a digital direct X-ray detector with input optic based on a FOD is developed for using X-ray microscopy and microcomputer tomography. In-house image processing software X-ray projection process is supplemented with an image capture modeler. A new effective algorithm for filtering impulse noise that doesn't cause image refocusing is proposed in implemented X-ray projection pro software. Research is planned on the effectiveness of applying the filtration techniques in MECO. That's all. Thank you for your attention.
Okay. Our last presentation is a presentation of Mr. Gleb Ryaskin. I apologize, Mr. Ryaskin, that you needed to wait us until the end of the session, but that is a schedule for today.
I think it will be better to share the video. And,
and later we will discuss it.
Yeah, if you will have a question, I will answer. And excuse me for my Russian accent.
Okay, it's totally okay.
Yeah.
Just I want to see if it's in program here. If it's not, you will share it, but I hope I have that. Switchable controlled operations with band functions.
Yeah.
That's
Right.
your presentation. Okay, I will now mute myself in order to avoid the double microphone.
Yeah. Good day, dear conference participants. My name is Gleb and I want to submit a topic by title Switchable Controlled Operations with Band Functions. Nowadays, using cryptographic ciphers is one of the best ways to provide secure communication, where standard algorithms IS, RSA and others are the most used encryptions to ensure the protection of communication networks. However, there are protocols in modern telecommunication systems that need to transmit information very quickly and securely. For example, Internet of Things. Those encryption algorithms are not suitable for use in such an environment. It's necessary to build an encryption architecture so that it's easy to implement and change the scheme in a changing and limited environment. To solve this problem, switchable data-dependent operations have been proposed. This mechanism provides the required level of data protection for high-speed connections. The objective of this work is to construct switchable data-dependent operation maximum protection against cryptanalysis methods. Other requirements this algorithm provides. The best way to provide security against crypto attack is using the non-linear functions. In this paper, new design of SDDO using band function have described, providing a high degree of security against crypto attacks. So let's start with architecture of SDDO. The encoding process is described on the slide. The architecture of the system is based on the controlled substitution permutation network. The choice of which control vector V to use is decided by the control element, bit of information. If a control element E is equal to 0, then the controlled vector V are chosen in one way, and if a control element is equal to 1, then the controlling vector V are chosen in another way. Therefore, one of the main functions of SDO is switchable controlled operations F and M. The encryption operation is designed as uniform controlled substitution permutation network, as I say, and constructed with a minimum size control element E to control vector V in case of fast encoding and easy implementation in FPGA. The main schema of CSPN is presented on the slide. Selecting a set of the fixed permutations connecting active layers, we define some particular topology of control operations. Choosing the right schema and control operation is a critical part of the development of a controlled operation blocks with the necessary properties in terms of cryptography. The slide shows the basic requirements for control operation. The main task in our research is to create the most stable cipher for linear and differential cryptanalysis methods. So the good way to use band functions. Band functions have the highest degree of non-linearity among all functions with a given number of variables, and as a result are widely used in cryptography to create ciphers that are most resistant to differential and linear cryptanalysis methods. So a band functions can be defined as a function that is extremely poorly approximated by affine functions. The band functions match the cryptographic criteria for propagation and maximum nonlinearity, but the function is not balanced. Band functions always have an even number of variables, so the controlled operation f21 not suitable for construction the band function, because we have an odd number of variables, but the controlled vector f22 is suitable with two controlled elements. Also, we need to add nonlinear function to band function to make the balanced output, where BF is a band function, F is nonlinear function. Only after this, those functions meet all the requirements and can be used in the system. Figure on the slide illustrates the scheme for this case. After that, it's quite simple to develop a scheme for implementing the switchable data-dependent operation algorithm into FPGA chips. In this research, we find functions that meet all the requirements for controlled operation, such as involutions, bijective transformation, and maximum nonlinearity, and it can be used in the system. Table lists those constructions based on the band functions and nonlinear element. Presented in these work, functions have an equal or higher nonlinearity parameter due to the use of band functions in comparison with existing algorithms. It can be used for making block cipher on switchable controlled operations. So the new design of switchable controlled operations using band functions have been proposed. Using those functions at the possible maximum nonlinearity and provide security against linear and differential cryptanalysis. This technology is very convenient for implementation in FPGA, but the band functions are not balanced, so we used to add a nonlinear element in our schema. So thank you for your attention.
Okay, this was the last presentation. Mr. Gleb, do you have something to add? Something to comment?
Maybe I would like to thank the organizers of the conference for the opportunity. So thank you.
Okay. Do someone has a question for Mr. Gleb? No.
Okay. Then thank you to Nina. Then thank you to all of you for today's session. And I will conclude today's session and wish you all the best for tomorrow. Obviously, we had a good session today here in room 1, also in all rooms, and see you tomorrow. We are inviting you for our closing conference, also to finish tomorrow all the program. I also invite you to join tomorrow keynote sessions, also to some project dissemination, maybe will be useful for you in terms of fundings and so on, to help you to find some funds and to join the projects. And also thank you to University of Ryazan, to University of Leti, because they are first time in this conference and they shown good responsibility to present good papers and to do good presentations and material. Thank you very much for tonight. Thank you.
Thank you. Bye.
Bye.
Okay.